happened that technical support head of ETAB, CSI, is here with us. Since 2008, is giving a technical support on behalf of CSI. Look, today briefing you regarding this program. Today we have a brief outlay of a comparison of IS 1893-2016 and proposed changes maybe with 1893 with the draft code of 2023. Sachi Parekh will give a brief introduction of it, and particularly today we are concentrating on soil structure interaction, because the reason is, we being a structural designer, normally we are happy with the SBC. We ask straight away to the soil consultant, the soil report writer, that tell me boss, SBC kitna lena hai, settlement kitna hoga. While designing analysis with RCDC or with SAFE, we are happy with the settlement, the crack width, the pressure under the foundation and all that. But thing is not that much simple. That is the thing that the CSI technical head will help us out. And today morning we had a talk that they will give us a free of charge template how to manage with the proposed changing coming with. Because right now we are using ETAB 20 or 21 version. But with revision and all others, it may take time to incorporate each and everything. But besides this, we as a structural designer may not get handicapped or have a solution readily available to us. That's why the team of ETAB is with us. I hand over the session to Sachi. She will briefly give outlay the influences, the effect, the probable changes and all of the similar kind of program was organized by ICEA. I think many of you may be there, may not be there, but just have a overview of the thing. We are doing this 15-20 minutes program because we want to take a total disadvantage of the CSI team over here. We want to explore that what the ETAB can do for us. It's a very versatile software. We are using it, and we all know that whatever may be the structural solutions, whatever may be the structural problems that can get solved with ETAB. And you all young buddy architects, civil engineers and structural designers, you are much more comfortable than me and Hiren, because we are at the age of 58. Besides this, we are here to learn. I request all of you, for the whole day, let's concentrate to learn. Ready? Okay. So I hand over to Sachi. Thank you.
Hello. A very good morning to everyone. Myself Sachi Mehta. Today I am going to present here the comparison of codal clauses which is currently using in as per IS 1893 and the draft standard of IS 1893 which we have received just 1.5 months back. Can you please connect this system? Yeah, okay. Thank you. So let me start with the current code IS 1893, which is consist of two things, that is general provision and the building. In the draft standard, what we have observed is they have divided this part 1 into two parts. Part 1 for general provisions and second one is for the building. So now we will get two separate individual stuff for both, for general provisions and for the building also. Let us talk about the history of IS 1893. In 1962, it was first published at the name of Recommendations for Earthquake-Resistant Design of Structures. In 1966, they have revised again. 1970 second revision. After that, within 5 years, in 1975, the third revision we have received. Then in 1984, fourth revision. Now if you see here, after 2001 earthquake, immediately they have revised in 2002. So that is the fifth revision we have received in 2002. In 2002, they have divided IS 1893 into 5 parts. Part 1 for general provisions and building, Part 2 for liquid retaining tank, Part 3 for bridges and retaining walls, Part 4 for industrial structures, and Part 5 for the dam and embankment. The current code which we are practicing, IS 1893, is been published in 2016. So if we'll see the gap, 2002 to 2016, so that is a very huge gap. And after 14 years, they have revised the code, and in 2022, they have published new code for the base isolation for the building. Now the current draft code which we have received, in the forward they have mentioned that it consists of 11 parts. Part 1 and Part 2, which we have recently received for the general provisions and building. They have separate, they are planning to publish for liquid published code for liquid retaining structures, bridges and retaining wall, industrial structure, base isolation building, pipeline, dam and embankment, coastal structures, steel towers and tunnels. As we all know that IS 1893 also impact IS 13920 and IS 13935. So they are also planning to publish this both code into 11 part in future. The current code having 7 section, and they have divided they have separated for sections for part 1 and part 2. Here they have introduced new both two terminology, that is earthquake hazard, and second is architectural element and utilities in part 1. In IS in part 2, recently we have received section 1 to section 4. Still section 5 to section 7 are not received, so hope we will receive that soon. If we talk about the seismic zone of India, currently we have 4 zones, 2, 3, 4 and 5. In the draft standard they have added one more zone, that is 6. Before finding out the zone factor, the draft standard has divided the category of structures for normal based on the return period, and for that also they have divided into 2 parts, that is for the strength design and for the serviceability check. The return period is different for both, for individual category of the structure. Gujarat is I can say a very lucky state, because it has all zone 2, 3, 4, 5 in the past, and in the current code also every zone is there. So as a structural designer, we have to deal with each and every zone. This is just I have just compared the zone factor, and as you can see, the zone factor has been increased for each and every zone, the value. Importance factor, so they have decreased the importance factor. In current code it is ranging from 1 to 1.5, and now it is reduced to 1 to 1.15. For response reduction for factor also, they have increased value of R, the upper bound limit. So if we talk about the building with moment frames, so it is remained same, but for structural wall the value has been also increased. For the soil classification, the current code has soil type 1, 2 and 3. But in the draft standard, based on the shear wave velocity, they have classified the site ranging from A, B, C, D to E. This formula for computation for natural period remain unchanged. For the as we know that the response spectra has been changed, so current spectra is up to 6 seconds only, and now they have extended it to 10 seconds, and that is also based on the PSH, that is pseudospectral horizontal acceleration. For the site class E, we have to deal with the site specific hazard assessment. For the computation of seismic coefficient, there is currently we are dealing with z by 2 I by r in an SA by g equation, and that also has been modified. And I have tried my level best to just compile all stuff into this one slide. Um, so this based on the serviceability and the strength design, it has been changed because the return period for the both is different. For the computation of seismic weight, the clauses remain very similar, or I can say unchanged, just they have changed the sequence here and there. For the load combination, the factor for the multiplication of earthquake load they have removed, because initially we have a multiplication factor of 1.5 or 1.2 for the strength design, and now it won't be there. For the irregularities in the building, currently what we are using, that is remain same for this part, but they have just regularized and systemized whole stuff. Current code has stiffness modifiers value they have given for only for the column and beam specifically, but for the draft standard, based on the limit state of strength and limit state of serviceability, they have specified the value of stiffness modifiers. Uh, Lateral storage drift, which is having a value of 0.004 as per the current code, but as per the draft standard, based on the earthquake zone, they have specified the value for each and every for each and every zone. They have specified the lateral storage drift value. For the minimum design horizontal base shear, we have in the current code, based on the seismic zone, the value is differing. But now we have to deal with the equation of 0.625 Z into I divided by R into W. They have also proposed the admissible structural system. So here, if we talk about Gujarat, in Surat, as we lies in zone 4, so we have to deal with SSW, that is special structural wall. And for SSW, they have also given a specific value that we have to deal with minimum this number. For design eccentricity, this also has been changed. If I talk about the structural plant density, currently for zone 3, 4 and 5, 2% the value is fixed. But for the draft standard, based on the zone factor, based on the earthquake zone, the structural plant density also been revised, as I have mentioned in the slide. For the separation between adjoining unit, irrespective of the level, at same level or at a different level, the value in current code is delta 1 R1 plus delta 2 R2 divided by 2. But now in the proposed draft standard, based on the floor which are adjoining to each other, based on that level, they have defined the equation. For the cantilever projection, this part also remain unchanged in the draft standard. If I talk about the compound wall, they have specified the value of I, R and SA by G as per the current code, but now it has become question mark. They have introduced new terminology as AU's architectural element and utilities. So current code is more concerned about structure and life, but now in the draft standard, they're also concerned about property and services. So now, as a structural designer, I can say to maintain the beauty is become our duty. So that is also we have to take care about. They have given a special part for the soil investigation, that is a specific clause, and it is like now in currently practicing, we are concerned with the modulus of subgrade reaction. So how can we compute it? So they have elaborate whole stuff into that specific clause. Now, the big question is how we deal with the current draft standard with respect to software backup and as well as geotechnical concerns. So we all have to come up together. We have to work with each other. We have to talk more, and I hope we can figure it out in a better way. So We have in the draft standard they have given this format also if anyone want to. So date is also expired, but yeah, these are the reference document that I have used. And thank you so much. Let's build a strong structure for Indian society together. Thank you.
Hello. Well, friends, thank you very much, Sachi, for briefly giving the outlay of 1893 2016 and 1890 draft code. We have with us Jainam as well as Manoj Bhai. They have sponsored this program for us. I request Jainam to please come forward.
Thank you everyone for your presence today. Thank you Sachi ma'am, thank you Kamal sir for giving us this wonderful opportunity to present here to discuss on the various standards of structures today, which is been changing drastically since the government has been updating the earthquake codes. So today we'll be speaking on ETABs. We'll be having our guests from ETAB company to help us with the software, and there will be a later on presentation on our product as well. So thank you once again for coming here. Thank you so much.
Thank you, Jainam. Thank you, Manoj Bhai. It's a good opportunity for all of us that Tata company distributor Manoj Bhai has arranged such a wonderful program for us. And I would like to share, I'm very happy to share with you that being a structural consultant, many of the times we are worried about the supply chain of materials. And you see, many of the time dumping on site a 10 ton of steel or 12 ton of steel is becoming a headache for us also. And he has promised us that now onwards, if you require 100 kg of 8 mm and 200 kg of 10 mm, they are ready to supply it on bari to bari basis. So for the smaller projects, many of the times on site, there are some issues related to material dumping and all others, because we are not using only the reinforcement bars, but a fine aggregate and a coarse aggregate for many of the small projects. Uh, because of the space constraint and all others, and local authority Surat Municipal Corporation just sent a notice to us to pay for the penalty. So he has helped us to uh, get rid of that penalty clauses of corporations also, and a headache with our neighboring. So I think this is the first unique approach adopted, and not only for Surat, but he has covered majority of the South Gujarat region, from smallest of village to the medium urban development area or semi-urban area, that his network will provide the Tata Steel, the quality steel to all of us. So we are very much thankful to you, Manoj Bhai. This is the first approach that you adopted. Now I hand over to Vivek Prasad. I told earlier he is a technical head of support system. So I think for we structural designer is our backbone on which we can rely, because he is the only authorized person from CSI who can guide us properly. Thank you. Thank you, Vivek. Please.
Very good morning to everyone. I'm Vivek from CSA Engineering Software Private Limited. I welcome you all for this wonderful discussion. So, on behalf of CSA Engineering Software Private Limited, I would like to thank uh, Mr. Parik for his wonderful arrangement, where we are going to discuss a lot of things, and Ms. Shashi for giving this brief introduction on the code, the changes, and today. Check, 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 check. Okay, thank you. So sorry for the little hiccups. So what we are going to present you today is the current ETABS version 21. Um, what are the features available in this to accommodate the new changes in the draft? That's what we are going to focus, and some emphasis on the specific modeling like soil structure interaction, right? And more about these seismic loads and other changes that we will have to make. So this program has been gone through many changes due to the latest changes in the codes and other things, features in the analysis. So this latest draft code, when it is get published, this will also get updated in the program. Meanwhile, this program at the current level is still capable of adapting to the new draft code. So right away you can use it. So those things I would like to share with you today. So let me, Ms. Shashi took away the pressure on comparing the codes. The drafts is already there. I believe many of you would have gone through that. So the changes primarily on the probabilistic approach from the deterministic approach that used for the estimation of seismic loads, right? So this, with this, we will have to change our inputs to the program. Although the analysis remains the same, the inputs have been changed. Accordingly, um, your outputs, especially the analysis results, how we are going to deal with the load combinations, right? So these things also will affect with the draft provisions. So let me skip some of these slides which I've already discussed. So the return period, that's what the highlight here, and you can see those for different zones as well as the return periods, right? So if I consider a regular building or normal building as per the category, you can see the categories of the structure. Normal, it is 475, and for the serviceability it is 73. For that, different set of Z values now we have to deal with, right? That means two sets of input are required firstly. So in this presentation, I want you to just focus on the changes. Don't worry about the numbers as of now, because it is still a draft. Debates and discussions are going on. Published, things will be settled. So, but the approach is not going to change. That's what I believe. So the approach is really good. This was much expected. And the second thing is the site class based on the shear wave velocity. I think the geotechnical engineer is more involved now, right, rather than simple SBCs, right? So we have to go through the various tests and test-based the procedure basically required for giving you the um, stiffness, how we are going to compute this. So there are formulas and procedures there, and now we have two sets of spectra. One is for the design, another one is for the service. So I'm showing you this small box related to the ETABs. So what you have to do with the ETABs with this new changes. Um, so this I will show you in the model itself directly. So it will be much better. So you can update this spectra very easily. So this is for vertical and then horizontal. And then the AH or the AB, it is now ZL2 I into a normalized spectrum. And this spectrum will be used accordingly for the strength and service categories. Let's go to general provisions in part 1. So performance expectation, that's what we are already dealing with, so no change in that. So we have classes that discusses damage, integrity, collapse mechanism, and what are the key elements, right? Structural and non-structural, right? How do you want to handle this in the program? Yes, you can do that. So program basically has, so far we would have used mostly the linear static analysis or response spectrum analysis, right? So program is capable of doing nonlinear static, nonlinear dynamic time history analysis, and you can also study the collapse mechanism. If time permits, I would like to share that as well. So you can even study an existing model, existing building modeled in ETABS, and study the current state, like over 25 years, what is the deterioration or other things, and if it's subjected to new earthquake demand, what will be the responses, like all this is possible. So basically we do that with material nonlinearity and geometrical nonlinearity. So nonlinearity is very good in ETABS. So for example, the plasticity is modeled on the members, like for the beams and columns. Based on the collapse mechanism, we can assign a nonlinear hinges, and you subject it to a static lateral pushover load or a real-time time history input as a earthquake demand, and you can study the collapse mechanism in stages, various stages. So it is wonderfully done in ETABS. So basically CSI products are not only structural, they are earthquake engineering based. So you have all the provisions or features required for these kind of studies, right? So one of the slides that discuss the pounding of structures, that can be easily done in ETABS, right? Two towers very close to each other, and you want to study in any stage that it might pound each other, you can easily do it in ETABS, right? Okay, then the attributes, lateral stiffness, lateral strength, yes, these are typically taken care. Yeah, and the last one is about energy dissipation modeling, like base isolators or dampers in the structure. This is also very much possible. We have links in the program, you would have seen this, but for most buildings it is not used. But when you use these kind of energy dissipating device, that can be modeled with the link elements. I think we are going to have one more code on base isolation, energy dissipation basically, that will deal. And then when you go to the design requirements, we already have the design features in the program that you are already using it, right? In conjunction with 13920 ductile provisions, right? So it is already there. So no change as of now in the 13920. So the design procedure remains same. The demand is getting changed. That's what we are focusing today, right? So the earthquake force, So the minimum design earthquake force is 1.5% now as per the new clause. So we'll have to ensure this. And significant change you would be seeing in the load combinations, right? So you can see the load factors for the dead and live, but for the seismic demand it is unfactored, and there are some new combinations for column members, vertical members with overstrength factor. I think this is yet to be decided, but so these are the significant changes in the load combinations, and then you have separate set for the serviceability. But the current ETABS, it has to be tweaked for these new features, but with the current ETABS you can always do it manually, which I will show you shortly. And then, yeah, the load combinations, you can apply these loads in a single direction. That's what we typically do, and two orthogonal directions, X and Y, and then we combine them in the load cases. So that is a standard approach that we all follow, but you can apply the other direction in the load case or the analysis case itself if you want to combine all three. That is also possible. So combining it in a combination is a very simple thing that we always do. So for the analysis, starting from the linear static analysis that I was already talking about. So you have linear dynamic analysis, a time history analysis basically, we call here response spectrum, model response, that is called as FNA in ETABS, fast nonlinear analysis, and you have matrix response, that is full-fledged time history analysis, and that can be model based or direct integration like Newmark beta method or HHT or Wilson theta method, all of this. So minimum base shear, the scaling that you usually do with the comparison of static and dynamic, that has to be done manually as earlier, that we will have to do. It's not automated. We don't automate that. We have to review, the designer will have to review the forces and then manually do those changes. But it's a simple thing to do that. I believe we're already doing it for the response spectrum cases. Okay, next. Sometimes dynamic may be higher in some structures, not in all structures. Most structures will be lesser, but in some structures it will be higher. In that case, then no need to scale. If scaling is done, then it will scale down the dynamic. So it's a one-step single thing that just review this and then update it. That's it. We want always you to review the analysis results a lot, rather focusing on the design of members, right? Members is just a click of a button. So when you see the analysis results, the interpretation of the analysis results is the key for a good design, not the design, just the design, right? So we have to arrive at the design forces correctly through the analysis. So that's what all we are trying to do in the analysis. So in the specific part 2 for the buildings, so the modeling requirements like the effective moment of inertia that you will be using, that we usually already we are doing it with 0.35 for the beams and 0.7 for the columns and 0.8 or 0.7 for the walls, structural shear walls. That will continue. I think it is unchanged in that, right? It is the same. So lateral drift limits have been changed. We'll have to see. So torsion, I think torsion has been enhanced further to 1.8 for the static, linear static analysis, and good that dynamic is not affected, or I think the 1.5 magnification factor is taken away, right? Only the 5% eccentricity is there. I think it is back to 2002 code now for the eccentricity. All right. And the torsional flexibility of the building, there is a new procedure, but this is something we'll have to wait and see how this manifests, because it is right away, it's just a procedure and you have to see what are the um, responses that you have to take in calculating and finding out the torsional flexibility. A new parameter has been used. Okay, it's just a quick comparison for a zone 4 building for the current code, and then below is the draft code. And you can see the change in AH, the factor that is going to give you the base shear. Seismic weight is unchanged. The AH, earlier it was 0.06, and in the draft code I assumed R value as 6, assuming that I'm going to take the full reduction with the help of moment resisting, special moment resisting frames and shear walls. Then it is still greater than, it's almost doubled. And there is a minimum value always. Now it is 0.015 or the other formula, whichever is greater. This can be defined easily in ETABS. I will show you. And yeah, structural analysis, we have the necessary features for the analysis and interpretation of results we have. And then we'll discuss soil structure interaction, modeling. Right. Now let's see this in action. Thank you, sir. So this is ETABS 21. Okay, change नहीं हुआ. Okay. So a significant change from 20 is that we have the detailer inside the ETABS now. So where you can do all the detailing things inside ETABS and export it to the CAD and take it forward. So that one big change. But our focus will not be on the detailer. Let's get back to our job on seismic analysis. So I prepared a simple model just for understanding these changes. So we have the current code. A simple RCC building, 4-story building with a fixed base. So the model is very simple. Our focus would be on the changes and how to implement this in the current version of ETABS. Let's start with the definitions. So the acceleration coefficient, so I'm skipping all those modeling, the other things that we have completed the modeling. Let's come to this point where we are defining the lateral loads, right? This is the current practice with the current code. So EQX and EQY. So we have ready-made features like this. You can directly specify the parameters from the code and let the program to take care of the list. So it calculates, basically it calculates the base shear and applies to the structure with quadratic distribution. So this is done neatly. No issues on this. Yes, sir. Okay. Yes. Okay. 4. Okay, good. Oh, okay. So this drop down list is like 2, 3, 4, 5 for the current code, right? Now this tweaks will happen shortly after this code is published. But we also have the user defined to put any different value, because we need to have a different value now. It's not a standard value. So we will use user defined. I will come to that in the second model. So this is just to give the brush up on the regular practice, and then we'll switch to this. So it's a zone 4 building, and we have these definitions for X and Y. Let's not complicate it too much with the eccentricities and other things. Let's keep it very simple, and then I will answer your questions if you have anything related to that. Okay, this is, and the section properties, I've been little liberal so that you don't get failed in the presentation, but yeah, you can tweak this, you can fine tune this with so it's a 300 by 500 beam and then 500 by 500 column. 6 meters is the column, I mean the span in X, and 5 meters in the Y direction. That's all. So I've used this simple arrangement here, uniform, right? So let's go ahead and run the analysis. And you can even perform the design of the building, but let's focus on, so we have this feature called story response plots, which will help you in deciding the structural configuration that you have made from the parameters like story drifts, story stiffness, etc. All of these are available under this. Lateral stories, I mean lateral loads to the stories or drifts. Right, just note down the drift. It is about 0.0027, right? Just less than 3. And we had also defined the response spectrum. Then we also have a feature that you can readily define this. Right. So we are interested in the modified or the draft code. Let me open this code model for that draft code, and I will show you what are the changes we have made here. This is it's the same building. So lateral loads, and you can see the predefined is not, I mean, it's not useful because for the current code it is different, the spectra are different, so we'll have to use it as a user defined. In that specifically I used user coefficient, which is also very helpful to quickly fix this. So what we'll have to do is, anyway, we'll have to work out the um, AH value, or the basically we have to find out the coefficients and tell the program this is the coefficient, and what is the distribution. It is quadratic, so it is k equal to 2. So this will take care of that, but that little part you will have to do currently externally. It's not legit. Yeah, I will unlock, sorry. Yeah, that would be better. So I used this particular what I had used in the presentation, like 0.125 for return period of 475 for the strength, and that is for the service it is 73 as per the table. So now we will have to define two sets. So one is for strength, another one is for service. The same model, same model. Everything goes in the same model. So I worked out as 0.125. I'm trying to give this. That represents the distribution factor. Whether it is linear, it should be 1, and it is quadratic, so I'm giving it as 2. Now our code directly suggests use the quadratic distribution. WH square, the summation of W, that formula. Ah. Uh, no, if you want to change the load pattern, see, we do this in pushover analysis. We change the load pattern like linearly or constant in all the stories. These variations we do. So in that it would be useful. Otherwise, in our case, default it can be 2. Same goes for the y direction. And then one more load pattern. This is for the service. So again, I worked out the AH, and it is 0.075 for the service. So this is, I think it's not visible, but this is for 73 years TRP. Again, you have to define two load patterns like this. The distribution again is the same, just the coefficient will be different. So these two definitions, And the next item in that would be the functions for the response spectra. So we need to bring in the response spectrum, new spectrum. So we have this response spectrum, the way you define same way, but this time we will use the from file option. Okay. This from file option, and we have created two spectrum, one for horizontal and one for vertical, just like this. This you can work out from the formula given there through an Excel and put it into a text file like this. Yeah, we can give this. You can generate this on your own, or let us know, we can share this template with you. Sure, sir. Okay. Vertical also is there, yes. This, you can see this, both. This is for the horizontal and this is for the vertical. So select this from file and add new function. You can give a name, and it is period versus value data, and you can browse this, and the file type you can set it to text, and then you'll be able to see that for the horizontal and for vertical. You will get it easily. For the 10 seconds. Okay, so I have already imported it. Just press OK and it will be there. So I named it like this. So you can see these. Once this is done, we can use it. So for the linear static that we have already done and given as a coefficient, so program will take care of the distribution. I will show that distribution also. And for the response spectrum definition, then we have X, Y, and Z direction definitions. So this is for the X, U1. I used site class C, so it is C, RS, and horizontal, so it is H. So the scale factor now, at this stage, we will have to include Z and I and R, all three. Because if it is predefined, then so you know that it is only G here. Now it is Ig by 2R, you will have to include as initial scale factor. Right. So rest of the things are the same. U1, U2, and for the Z direction you have U3, and function is vertical function. All right, let's go ahead and run the analysis. So under the display, I'm going to show the plots, and specifically we want to see the auto lateral loads to the stories or the base shear. It is 1478 kilonewton. For a similar building there in the based on the previous code, we'll also compare this. This is 710 kilonewton. So that's a huge difference that you can see. 710, and here it is 1478. This is for strength. Note, this is for strength, and you have one more definition which is prefixed with small s in this model, which is for the serviceability, just to differentiate that. And it is 886 or close to 900 for the service. So we will be using this particular output for the service checks. In case, all right. Now we got two sets of outputs. Again, we will have to deal with the load combinations now. I'll show you how to do this. So for the draft code, I have prepared these load combinations. You can see. Especially the seismic, we'll be using the load factor as 1. Dead load is 1.5 times. Right. So we'll have to deal with the signs, positive and negative, for all the sets we have already seen here, these combinations. The first set for the strength. So how did I create it? With the help of a spreadsheet, which I want to share. So we have the option in ETABS called interactive database editing, right? What you can do, you can create a copy of it and modify it and bring it back as a new definition. But you have to be very careful at what is the name of those particular load cases or the load patterns that you have defined there. So for the current code, I picked up like this: interactive database, load case definitions, load combinations. So we'll get this, and you can take this to Excel. It's kind of similar, except the load factors are now different for the seismic. So I copied these. From the current to the modified, the draft code, and modified it like this. And I copied it to an Excel spreadsheet like this and modified these factors and the names. You can see one and other locations and one more set for the service. So 72 combinations are there now. Once this is prepared, you will go to the model and you will use the interactive database again. Load combinations. Just define one simple combination for populating this table and then you can take it to Excel. In the Excel, you simply copy paste the updated data, that's all. So we have these data which is already populated here, but you just need to do the copy paste of this. Once this is updated, you apply this to the model and press done. And then you'll have all the load combinations like this. You can prepare a template like this and you can use it in any model in the future also. It will be very easily. Although it get updated when the code is get published, we will update the program accordingly. So till then you still can do all these updates manually. Just a little bit of work, but worth doing it to do. So there is no restriction with the automated features. So always you get the manual or user defined options in the program, right? All right. Now, so with this, let's get the analysis done for both codes. And we are looking at the drifts. Let's check for the current code. Point 0027, and in this one for the draft code we'll have to use the SEQX, that would be the serviceability, and it is 0.0034 now for the zone 4 building. And what is the limit? I think 0.03 or 225. No, new code is different. It is 3. Exceeding. Even after that generous column size of 500 by 500. So what we are left with is nothing but introduce the shear wall to contain these kind of lateral displacements. So indirectly, in my opinion, they are forcing us to use the shear wall, not just the frames. But a simple shear wall placed correctly will give huge benefits for especially for the lateral drifts and the stability. So this is just a quick comparison. on the drifts. What is a new code suggesting that accordingly we'll have to do, but it is the same for both. Modifiers are same. Concrete building you can see it's 0.35 and is also 0.35. 0.7 and 0.7 for the columns. I'm not sure, sir, but the cracked section is what the key that we are trying to model here. So in an event of earthquake, the section is cracked. That is what we are trying to capture, whether it is service, or it's serviceability. So both are same actually. For other deflections such as long-term effects and other things, we can have the full, but that will be changing differently as part of the procedure analysis procedure. But here, lateral load analysis, it is a cracked section we have to model. So that's the reason I believe it is 0.7 and 0.7 for columns. Yes. Right. Right. No, it considers internally.
Okay, so we need not to give
Need
minus
not
sign
to
for
specify.
for
Even program will not allow you to specify negative value.
okay, okay,
Program will not allow you to give negative values. It's only a positive value. And you should also understand the response spectrum is always gives you a SRSS. So it is going to be a positive value always. So we are going to deal with the results, right? So it's not the analysis will have a negative and positive. It is always positive. So that's why we in the program already in the design it is taken care of with 8 sub combinations, P, M, and M. Yeah. Okay. Right.
For slab and wall,
Okay.
new modifier introduced in draft code.
I think 0.35 they are given, right?
Yes,
Right.
for both the case there is membrane and cell, both properties are available.
Okay.
Which property will use to give a better result?
Okay. So this slab is, I mean, this modifier is possible only for shells.
Okay,
Membrane does
yes,
not have out of plane behavior,
yes,
first of all. So even if you apply, it doesn't have any effect.
okay.
So it depends how you model this slab itself.
Yes, for a cell is effective for these properties.
Yes, you
Okay,
have to use shell to
okay,
have this property.
okay, thank you.
Yeah. Which one? Okay. No, no, just a moment. Design excellence, just go there. This will be eccentricity ratio. It's a ratio only. It will take both in the analysis actually. I don't know why this is accepting. But if you specify the overrides, I think this should be, here you will not be able to. Here also it is accepting? Okay. Okay. Yeah, the negative sign is there in the code, but in response spectrum, what we actually do is the eccentricity is captured, right? The inherent eccentricity is also there, and then anything that you specify will be in addition. But this is captured separately as internally as separate load cases, and it will be added or subtracted. So it will be a different procedure slightly, right? It is basically plus or minus. For response spectrum, you don't have to specify. Let me check it and verify it and come back to you on this. You don't have to, but let me see. Any more questions?
Different spec X and spec Y. That
Yes.
one can how one can do that.
Okay. So in this model, we had used in spec X 100% spec only one direction. The direction you are talking about, right, sir?
Yeah.
So you can include the other direction also to have the effect combinedly,
Yeah. Okay.
right? So if we were considering it as 30% or 40%, then multiply it with that factor and apply it here. Yes. So here you can add u2 direction, that is y direction, and it is the same function, and here you can make it 588.36, let's say 30%, and you will have the effect. Actually, this will be more realistic than handling. Vertical भी add हो जाएगा. We can consider vertical also here. But then you don't need a separate load combination with again a 30 and 30 for x and sorry, y and z. If already included in the analysis, so it is already captured. So what the general practice is, you have it separately. You have 3 sets of results and then combine them in the load combination. That's what we do in general. But if you wish, you can combine them here itself.
The results are same basically.
We will have to see. Effects may be slightly different. I expect something
So the what should be
with the model combination. No, as per the code, they are giving handle it separately,
okay.
right? But I think in research and other things, they combine these, especially for time history analysis. So response spectrum is a simplified time history, shortcut to the time history, where we want only the peak value for the design. So it is a design oriented analysis,
Yeah.
not a full-fledged. So we have the time history analysis, we are going to do that. So we have, when you have time history analysis, you get the full response with respect to time, and then we can design accordingly. Yes. Yes. No, no. Certain things we strictly follow the code. Then it is suggesting to handle it separately and add it in the combination, then we'll have to follow that. But I'm just showing what are the options available. If you want to combine this way, you can combine that. For some structures, see, we have seen many buildings designed only as a building. There are other structures where the masses are distributed differently. There you can find these the effects are much more significant. Right? The distribution of mass is also very key for choosing which type of analysis. For buildings, I think it is simpler to handle it separate and combine them in the load combination with 30%, 30%. That's what code is also giving. Even in the new code, it's also given clearly that way. That okay? Okay. So this comes from the basic assumption how you idealize the slab for your superstructure analysis. If I consider my slab as just a horizontal diaphragm, then membrane would be sufficient. We assume that the slab is stiff enough in its own plane, right? That's why we make this rigid diaphragm assignment and assign them, right? And then the flexibility or the deflection of the out of plane deflection of the slab is not of interest. What I assume is my superstructure or the frame, beams, columns and walls. This is what our analysis member, structural lateral load resisting member or gravity load resisting member. Slab is not at all. Slab is only to transfer the loads to the supporting beams. In that case, you will go with the membrane, right? Otherwise, if you know, especially even if it's a beam slab system is just that floor slab is distributing the area load to the beams, right? Supporting beams of the slab. Even in that case, some slabs are spans are larger. I mean, trying to say is larger spans. We expect some deflections. When mass is concentrated on that floor, then we will have to model it as a shell to capture that effect. So in that case, we'll have to go with the shell, and that shell with the lateral displacement, it's tend to go out of plane also. In those situations, you will have to use the cracked section. Then the slab is also getting cracked, then will that 0.35 modifier is applicable. Especially this is in simple classification, you can say beam slab, that's membrane is fine. Flat slab system or flat plate system, you need to go with shells. Simple classification. But even with beam slab, you have to think and decide. The designer should think, am I expecting?
Then slab should be designed according to the stresses in that slab only, not for by simple movement coefficient.
Right, moment coefficients, that's based on yield line theory,
Yeah.
right? So that assumption is still valid, but this property modifier is only focusing on when the slab cracks with the lateral oscillation, the stiffness is lost. So load transfer, right, everything will affect. So that's the reason they are reducing the stiffness of the slab, and then the deformations will be much huge, right? And we are trying to capture that. But this is not something as single point answer that I can give. That's don't do it, always. So that's why we are here. If that is not there, we will not be having an office to sit and work. Everybody will be done by a clerical fellow, right? So we have to think and work. We have to study the model basically. That's what we recommend. That's why lots of analysis features are there. We will see shortly in another example, the time history, the responses, other things. You'll get a fair idea about what's happening with that. But I'm still keeping it as membrane just for giving you this input. Yeah. Okay. So basically, if you think about the energies, right? So slab deflects energy is taken care, and then beam is also sharing with that. So there will be some reduction in the beam forces also with the shell, right? If you're considering everything as a monolithic thing, then you have to design it based on the elastic results that you get from the stress results from the analysis. Yeah, distribution. Yeah, then coefficient method is not useful there. So it will the beams, all beams should be a T beam at least. So T beam, and the slab will have this. Then you'll have to use the elastic moments that is reported. Based on that, you will have to design.
So then the mesh sizes would be of great significance.
Yeah, mesh effect will be there. But typically 1 by 1 should be okay, unless there are some specific concentrations, openings, then you have to reduce it accordingly for better stress distribution. So meshing is also a key in your finite element. Basically, it's a finite element analysis that we are dealing with. So
When
mesh.
we define the shell, then shall we reduce it to 0.5, or if because we have to take the results of the movements from the stresses into the cell element.
Right.
So for such cases, whether it desirable to have a reduced size, or 1 by 1 would be the.
No, no, we have to reduce at stress concentrated areas typically. We'll do that in finite element.
Yeah.
Like a column support, reduce it to 0.5 by 0.5 at least. Away from that, in midspan and all, you can have 1 or 1.5, still it will be okay. That distribution. So program is having the capability of assigning a simple rectangular mesh or a general mesh. General mesh is much enhanced. So program knows where the concentrations are happening, so it will mesh finer closer to that. You can utilize that. You can try that, especially in a arbitrary shaped plans, something like that. Then you'll have a general meshing, much more useful than a rectangular meshing.
Stiffness modifier slab also, right? So if we are defining the slab as a membrane, so do we need to provide stiffness modifiers in that case?
No,
So 0.35 is not there for the membrane case.
bending
That
stiffness is zero simply.
okay.
So applying a factor will not have any effect,
Okay, okay.
because uh, think just about finite elements, not the code. Forget about the code. If it is a membrane, doesn't have the bending stiffness at all. So applying any factor is not going to have any effect, right? Only shell will have that, right? So then again, when to use? Then you will have to study the model. When you are having large spans, better go with the shells. Small spans like 5 meters or 6 meters, I think it's go okay with the membrane still. Then code enforces certain rules like this, then we'll have to obey that also. That is different. But the idea, just get the idea how it is to be seen. That's what my point is. No, rigid diaphragm you can define. You can define.
Even if we can define as a shell, then we can define the rigid.
Yes.
But then the purpose will not serve.
No, no, no. Rigid diaphragm will only contain the in-plane deformations. Out of plane is available. Shell you can model, no issues. Out of plane will be there. So in-plane forces will be negligible or almost zero in that case when you apply a rigid diaphragm. It's assumption-based constraint. It's not something that you have to apply to everything, right? You have to study the model before applying the rigid diaphragm, first of all. Just run the analysis and see the behavior, especially the modal analysis results, where you'll get to see the mode shapes, mode 1, 2, 3, right? At least first 5, 6 modes, you'll get the clear picture. So let's say you have this you can see easily. Let's say a lengthy building, let's say 20 meter by 100 meter or something like that. Then if you see a mode shape, then it will have an arch kind of action, right? Then you have the one edge of the building, longer edge will go into tension, the other one will into compression. If you assign a rigid diaphragm straight away to that before studying this, you will neglect or miss the, right? So you have to study the model and then decide which diaphragm is suitable. Then you also have the semi-rigid for that use. You can go with. So um, so computers are nowadays are really fast. You can go with the semi-rigid also. But please study the model. Go in increments. Don't assign any constraints right away. Right. No, semi-rigid as such, there is no rigid diaphragm. Actual model only. The only benefit you are going to get is how the loads are applied. So in semi-rigid you assign some eccentricity. Then at each column node where the loads are acting, then there will be locally there will be moments applied to create that torsional effect that you are expecting. This is for torsional analysis, the twisting of the building, right? Accidental torsion, basically. So you have the semi-rigid diaphragm for that. The actual only in-plane deformations are there, then axial forces will exist. Everything will be the same except this twisting effect. You can do that. No, it is the same for the new code and the old code, the current code. Only, yeah, only the values will change. Right. No, no. You're asking about how to apply this eccentricity or reduction you are talking about? Okay. Okay, you're considering about this one, this particular problem. Mm, I think the primary force will be on this one only, U1 only, x direction only. So I think you can consider this eccentricity with this. But see, this example I wanted to show you the options available in the program, but you are strictly following the code, right? And then these are to be handled separately only, right? So in that case, it will be very simple. Is the code allowing to do that? If you turn it off, it is 1. Okay. Yeah, the 1.4 is, we will have to wait and see what happens after this one. Yeah. See, basically, I believe the code, who are working with the code are trying to get better strong column weak beam implementation and contain the drifts and other things, pounding effects and many things that we deal in earthquake engineering, structural problems. The whole idea is based on that. So, see, when there are more offenders, stricter laws will be there. Everybody will be penalized all together. It doesn't matter, I go do a better analysis, doesn't matter, just put 1.4, that's it, do it. So this is something beyond our hands. Stricter laws. Yeah.
The offset, then it will cut from the top only the beam movements. So I don't understand really why it is just cutting from the top only.
For the column you are talking, right?
Yeah, column or beam.
Beam, okay.
Yeah, particularly the column.
Okay, yeah, column. So you'll see the reporting at the soffit of the beam, right?
If we have a center to center line model,
Right.
then suppose top and bottom moments are equal.
Okay.
Suppose now we give the automatic options, then it will cut from the top only. What is the reason?
Okay. So that nothing but, see, I think this is false field. So we have the beams depth model below the floor level, right?
Yeah, I understand.
So this is at the soffit of the beam where
Yeah.
we assume this joint, beam column joint, to be rigid,
Yeah.
or how much rigid that you can specify. But
Yeah,
so the flexibility of the column starts just at the
I
soffit.
understand.
So
But
okay,
no, but I understand. But why? See, if it, this is the column,
okay,
this is the free length,
right.
then the joint have a same rigidity at the top and as well as the bottom.
Okay.
No, I understand. But it will not reduce from the bottom. It will just reduce from the top. Yeah. 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 But the center to center line distance is same. Yeah. Yeah, but technically it should be model the center to center only, no?
Now you can change the default settings to center, like
No, I understand,
not,
but there is a
Changes in the depth of the beam. If you are changing the depth of the beam, what is the rejection? Here is the 21 inches beam, and over here is the 600 thick beam, and maybe it will create a fault.
but you can take the control and you want specify how you want that. So default model is top center, number 8 top center will be there. The beam will go down, the depth will be below the floor level or the story level. Top, the flushing. Yeah, yeah, sure. extruded. So this is the floor level. Yes, sir. If we select, so the line element is connected, all the line elements are connected at this joint, and we assume that beams are typically modeled below the slab, right? So if the depth changes, it changes in the downward direction, not up. So that's the reason. So the end length offset, that program is automatically taken from the connected member easily. Uh, if you just put 0, then everything will be based on center line model. I think this should be sufficient. I think the 456 also advising us to do the design at the face of the member, not at the node, especially where you have the unusual peaks in the zone, this junction. So it will be uneconomical also. Yes. So please have the mic. Yeah. Acha.
Hello.
Yeah.
For a column case, there are column length is 750 or 1 meter. At that time, there are two beams in a same time. Okay. For we will connect for a center at a one time. Beam is on a beam portion at connecting of this beam. So moment and all the will we will release, but actual they will connect with column. At that time what we will do.
Yes, sir.
If I model it now,
Okay.
in actual that beam is resting on column itself.
Okay.
But in model, because of certain limitations of the software, it is positioned just near to that column.
Okay.
Many of the times just on the edges of the column. And he says that I am releasing the moment over there.
Okay.
How software will take it at the time of analysis.
Insertion. There are options. You can deal with the insertion of the frames, how it is getting connected to the other member, and there is an option to enable the stiffness for that, for the offsetted position. When you do that, then the effect will be captured. That is one thing. Some people will also use links, rigid links, just for that, but you lose some benefits of the in the design part. When it's connected to the column, then the beam column capacity ratio, that will be happening automatically. When you do it with other members using a frame element with higher stiffness or rigid links, then you will lose that. Or you can try the insertions and let us know if you're, then I will help you with that. Just let us know if you're okay with that. Insertions, frame insertion. I think that is coming from the display of ETAB itself, where you get to see the columns shape, the size, right? And then we are connecting everything in the center lines. Right? It is given for some other benefit. It is getting confused also, but you should remember that we are dealing with a line element, right? And it has only two joints. Every other member is getting connected to those joints. And whatever offset we specify, then that will get, taken into the account for the analysis. Yes. Okay. Rigid zone factors, it is also kind of assumption, but practically what we can do, it is the recommended value is 0.5 per RCC structures. So basically this joint, this junction, beam column junction, how you consider is it a rigid completely 100% or it is flexible? How will you measure this? No idea. There are no exact way to find this. So for typically for RCC, it is recommended 0.5 as rigid zone. So what is rigid zone? It is rigid 100%, and if we make it 50%, then for 50% of the offset will be rigid, rest of the 50% will be flexible. So between two ends of the flexibility extremes is where the frame is going to bend. If you put 1 as rigidity till the column face, the beam will be flexible. 0.5 halfway through, 0 joint to joint. That will have effect in your analysis definitely, right? So but that is something you have to assume and apply. 0.5 is the recommended value for RCC. Sure. Okay, it is just a display thing. Three locations. Okay, I got the point. Top, bottom. So you can comfortably change the terminate was. Okay. No, it depends. Some codes, international codes are specifying to use the maximum value throughout. No, that's a general. I'm just giving the background of why program is giving you that, but we will have to find out a way to. Let me quickly check. I think there is an option. I think design में तो आएगा नहीं है तो analysis में आएगा design में नहीं आएगा. No, sir, cannot change this. For analysis, you can change how many number of outputs you want along the length. Sure, sir, sure. We'll consider that. We'll discuss and let you know of this. No, no. Tables. No, we can expect only in. Oh, three locations always. I think table would be much easier way. Display में आ जाएगा वो तो. Yes. So when I right click on this, for each combination it will be 0, mid height and then the top. So इनमें से जो भी whichever is higher, that is what displayed in the graphical output. No, 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 no. No, sir. Right click करने से जो 2319 is the for the critical combination. So when you right click, it will directly point to that envelope. टेबल्स में पता चल जाएगा, एक मिनट सर. So we have summary and details, two outputs. Let's focus on column design. Right, इसमें पता चल जाएगा सर आपको from the summary. So you can see different combinations here. सबसे ज़्यादा जो है display is something, because it will be too much populated in this small screen. Mostly we'll be working in our laptops, and that much detail you have to zoom in and zoom or zoom in. So that is,
Consumption of steel will also
we understand. Definitely. All right, sir. All right. So coming back to the analysis, let's move to the design. Design, there is no change. So only thing we will have to do is including these new combinations, because it is not automated. So we'll have to go to the concrete frame design, select design combinations, and include only those strength combinations that you just defined. Right. And then perform the design. Hmm. ये भी hopefully somewhat visible. Okay, na? Little hard. So steel has gone up 30 नहीं होगा sir. I expect 15 to 20%. In this one,
Take the real time model with the actual building, it comes.
वो तो है. I accept.
ये BIS का problem आपका नहीं है.
We cannot violate the code. I think beam column capacity also playing here. 1.4 that. वो भी तो that we don't know what is going to happen to that. When then I think so. Even I don't think so. All right. So these are the small things that you will have to do manually to utilize all the draft code provisions for your analysis. And the design is the same, so no worries about the design, right? Only the input, spectra, load combinations. Only these three things. Okay. So time next time going to. Okay, AEU.
Yeah, because in draft code they have give some data regarding this AUs, architectural element and utilities. So how software will implement those all stuff?
Can you give me any specific class or?
Yeah, yeah. Just give me 2 minutes.
Yeah, yeah.
Prasad, actually what happens with this 1893 draft code now, there are specific provisions for AUs. Now AUs are, suppose this false ceiling is over here, then there is a HVAC ducting,
That.
and again that fire lines and all other. So the category of loading is, it is in the category of SIDL, that fire ducting, fire line having a dead weight of the pipe itself,
Okay.
plus as per the diameter and length, there is a per running meter load of that water inside. Similarly on terrace with waterproofing, the solar panel is there. Simultaneously on terrace with solar panel, there are some loading due to the HVAC instruments and all over there. So how, being a structural consultant, we should incorporate with that model itself.
Okay.
Suppose this is dead load, so running load, so we should give that load to that beam or for the slab
Slab.
or for the specific beam, because it becomes a very crucial and critical thing for a structural designer. Many of them, what happens, that beforehand, now architect learns that their presentation drawings are not the working drawings. Now that architects has learned, so they give us the working drawings. Up till now, actually up to our generation, we are happy with that presentation drawing, and we start designing and detailing. Okay, so these are the loading many of the times that HVAC people are not also not confirmed, because they says okay, my ducting size will be 32 gauge, but many of the new budding engineers that never understand that what is that 32 gauge plate is.
Plate.
And for that dead weight with their sizing 750 mm by 450 mm or 600 mm by 450 mm, so that load we need to take into account, and we need to incorporate with the our ETAB model also.
Okay.
Now with the AUs, they says okay, if it is sliding or it is subjected to toppling over, and rocking effect also they have considered. So actually, with today's, we are definitely going to talk with it AUs, but if it's come over here now, so I'm just shifting that matters. Regarding other elements for the AUs like the furnitures and all other. Okay. Many of them I designed this floor considering that yes, fixed seating is there. So I says class 4 kilonewton square load is enough for this. But besides this, lot of things we have placed over here. That platform. Again with that platform, that seating arrangements and all other. It may take care of it. But many of the heavy equipments are also loaded, and they are subjected to over toppling or rocking or all others. So with ETAP, in which load pattern or in which load category, we need to take care of that loadings. Over toppling and all other. Ha, ha.
What it says that according to the latest updates in the draft code, if the total mass of the AU is more than 1% of the total mass of the whole building, then all the AUs shall be incorporated in the structural model while analyzing and designing the tall buildings. So generally what we are taking is we are averaging out and we put it as a floor load. Okay, but what now they are specifying, if the mass of AUs are if more than 1% of the total mass, then you have to define it in your model itself. You cannot generalize it and take it as yeah. What they are proposing.
Actually, right now what we are doing, that I asked my HVAC consultant, okay boss, tell me the duct size of the ducting. With that gauge of all others, we consider 0.2 or 0.3 kilonewton per meter square of loading for the ducting and all others. For the fall ceiling, we ask the Armstrong people that tell me the dead weight of it, then suspenders and channels and all other. Then we work out it, and as SIDL, we load it. And if you are specific enough now, then we separately make it a different category of loading, not instead with the regular floor loads. Similarly for the fire lines and all other, if it is normally, it is kept on the edges of the rooms and all other now, so on specific that beam, the running meter load we are applying, right?
Oh,
I am not talking of the load. Why they are asking us to model it? Because they want
Why we are worried about is because ultimately that responsibility lies with the structural designer.
Right.
That's why we are worried. That's why we are worried. कि we manually calculate the load, we apply it, and we are going ahead with some approximation. If some vibration or we observe now, then says let put the importance factor 1.5. Add it. Go
Yes,
ahead
sir.
with. डिजाइन देना है ना, फाउंडेशन 24 घंटे में चाहिए, क्या करेंगे कि और डाल दे, निकल जा। पर इसके लिए कुछ मिस टुगेदर टुगेदर इट्स अ क्वेश्चन not from us but is for the ETEP people also, that we need some clarity input from, and not only that, I know there is a data sheet always. There is a data with all equipments. There is a data sheet which gives its dead weight, their dynamic weight, as well as that if the rolling equipment is there now, then the frequencies and all other that gives. That we need to incorporate with our model, because if that frequency matches or mismatches now, then it creates a problem for us. Structural behavior will be okay, model behavior will be okay, but afterwards, during that critical time and critical period, our structure will fail or its foundation of that specific equipment will fail. That we need to take care with our team, right? I think this is my opinion. Right?
So just to add that, the idea of this particular class is specifically more about equipments that is having certain frequencies in operation or in extreme its peak operational. So it will have its vibration as well as the frequency, peak frequency, which can resonate and increase the failure of the structure itself. But this is kind of special studies we always make, not in general structural modeling, because it has to be done in certain way. We have to perform a frequency domain analysis, like steady state analysis, to find the frequency and the resonance, what's happening. This can be done in SAP 2000 program, not in ETABS, but this is very specific, where a machine foundation or an equipment is mounted on a pedestal and operating with a certain frequency. So, so mostly this will not be having a structural effect, overall structural effect, but local effect. If it is mounted on some pedestal or in this floor, say let's say an MRI scan machine is kept, these are called primary structure and secondary structural interactions, and the resonance it is going to create. So it might be typically mounted on a isolator or bearing, some kind of different types of bearings are there. It will be mounted. Let's assume that it's operating at a certain speed. Uh, Mostly it will be causing a local effect in the slab. So we have to focus only on that part and ensure. And what we can do for in the design perspective, what we need is the peak load. Even if that happens, the peak load, dynamic load, which is converted into a static peak load, that can be applied to the structure and go ahead with the regular design. But if you were trying to study much in detail about the frequencies resonance are happening or not, and how far away from the resonant period, then you'll have to perform a steady state analysis, frequency domain analysis. So SAP 2000 is the program, right program to work with that. People are using it, so we can always use that. But ETABS is more focused on design office. So that is a research oriented, and you will have to use. No sir, no sir. It is also derived and found out that the dynamic forces will also be to a certain static level only. It's not like completely going off. So we can estimate that. So these analysis will help. Once the local model is analyzed in SAP and you know the loading, and then you can implement in ETABS as a point load or a line load or anything like that. Yeah, you can model that basically. All right. So I think with that, these are the things you will have to do to adopt to the draft code. Now I will switch to soil structure interaction, like certain things on the modeling. Let me open.
Hello.
Thank you very much. It was a, I think, uh, existing session, but I am very happy to see that young budding engineers are interacting with the CIS team in a detail and in depth what we have envisaged and expected. Thank you very much, young friends, because you are future of India. Huh? Now the responsibility of safe, stable structure, huh, lies on you. And I think the future of India is safe with all of you. Because in the manner, in the way in which you are involving yourself with the integrity of the softwares, I must appreciate that. I must appreciate that. I am thankful to Vivek that this is the first workshop I have observed in which August House is interacting freely with the supporting team of CIS. And I think in the CIS history also, the manner and the way in which they are going into detail and in depth now without hiding anything. You see, look, the thing is how transparent they are. They says, yes, this is possible by this way. And you see how the support team says, if IS code says that from tomorrow we are implementing 2023, they are ready. And one more thing that I am going to share with you. In the morning, Hemant and Vivek says, that we are giving you a sample template model. Just you start with the template, the things what he has shown over here now will be ready with you. So you are very lucky enough. And I am going to share you one more thing is, CVR Murthy Saab is also sending one dossier for all of us that we will share with our all friends free of charge, free of cost. It's a knowledge sharing platform. We are bullish to share the knowledge. And here I take the opportunity of 2 minutes that in Surat we have a Setu Foundation inspired by CVR Murthy. The concept of sharing a knowledge, sharing a technology, and I, Hiren, Sachi, and daughter of Hiren, Vidhi, we have initiated that process 3 years back. And we have continued some programs on it. This program is also a part of that Setu Foundation. And Setu Foundation is specifically meant for, as per the instructions of CVR Murthy Sahib, is for women entrepreneurs, for girls, those who are interested to go with structural designing. Yes, Setu is for you. We are ready to share whatever may be available with us with the help of Vivek, with the help of Hemant. Thank you very much, Vivek. We have one more interactive session. I told him, okay, it's an exhaustive thing. Let's digest it. Because transmission and receiving is a process. We need to digest it also. So I'm giving the opportunity to Manoj Bhai to share his views. Thank you, Vivek, again. We have one more interactive session, similarly for the soil foundation interaction. Okay, you can call your friends. Yes, join us. Come down over here. And one thing is, Manoj Bhai has shared a link. I have shared it to the many of the groups in all over India. So it's a live streaming of this program. And I think I have got the message from H.J. Shah Sahab. He is right now in Baroda, but he says, I'm enjoying over there. H.J. Shah is an authority considering the structural designing is concerned, and even at this age, we are referring his books of reinforced concrete design. Thank you very much. Thank you.
Thank you, Kamal bhai. Thank you, Hiren bhai. આપ સૌ આપનો કિંમતી સમય અમને આપ્યો અને ખાસ કરીને કમલભાઈએ અને હિરેનભાઈએ જે અમને આ મોકો આપ્યો છે ટાટા ટિસ્કોન વતી, હું અરિયન સ્ટીલ વતી આપ સૌનો ખૂબ ખૂબ આભાર માનું છું. અને હું કમલભાઈને રિક્વેસ્ટ કરીશ, જરા આવો, અમારે તમને ફેસિલિટેટ કરવાના છે.
મનોજભાઈ, આવું કંઈક પણ અમે ખેલ લાવીએ ને ભવિષ્યમાં, હા, કે આવું કંઈક ટેકનિકલ સેશન કરવું છે અને સુરતના, ગુજરાતના ઘણા બધા મારા મિત્રો આવવાના હતા પણ નથી આવી શક્યા. આવો કંઈક બી ખેલ લાવીએ ને ત્યારે તમે દિલથી અમને કહી દેજો, અમે તૈયાર છીએ. થેન્ક યુ.
હિરેનભાઈ સાહેબને રિક્વેસ્ટ કરીશ, આપ સ્ટેજ પર પધારો.
ખાસ યંગ જનરેશને કહીશું કે આવા ઇન્ટરેક્ટિવ સેશન્સની અંદર જમવા ખાવા કરતાં નોલેજ લેવા માટે આવજો. શનિ રવિમાં બધા તો ફરો જ છો, સાસ બી કભી બહુથી બી જો છો, પણ આવા સેશન બી એટેન્ડ કરતા રહેજો એવી નમ્ર અપીલ છે. થેન્ક યુ.
હવે હું રિક્વેસ્ટ કરીશ શ્રી હેમંત સાહેબ, CSI પધારે. શ્રી વિવેક સાહેબ પધારો. હવે આપણે લંચ બ્રેક રહેશે. પાછળ લંચ બિલકુલ તૈયાર છે, બધા લંચ કરી લો પછી આપણું નેક્સ્ટ સેશન ચાલુ થશે.
મિત્રો, મારી એવી ઈચ્છા છે કે નોલેજ શેરિંગ માટે ભેગા થયા છે ને, આપણે બહુ જ ઝડપથી જમી લઈએ. હિરેનભાઈ તો એમ કહે છે 20 મિનિટમાં જમીને પાછા આપણે અહીંયા આવી જવું છે. તમારી શું ઈચ્છા છે? ડન? હાઉ ઇઝ ધ જોશ? હાય સર, થેન્ક યુ.
ગુડ વન.
સર
અરે ચિંટુ, તું અહીં?
હમણાં જ આવ્યો દિલ્હીથી.
એમ?
સાંભળ્યું તમે ઘર બનાવી રહ્યા છો?
હા હા, એન્જિનિયરજી અહીં જ તો પાછળ.
અરે વાહ, પણ ટીએમટી રીબાર કયું લીધું તમે?
ગુડ વન.
સર
અરે ચિંટુ, તું અહીં?
હમણાં જ આવ્યો દિલ્હીથી.
એમ?
સાંભળ્યું તમે ઘર બનાવી રહ્યા છો?
હા હા, એન્જિનિયરજી અહીં જ તો પાછળ.
અરે વાહ, પણ ટીએમટી રીબાર કયું લીધું તમે?
ટીએમટી રીબાર લઈ લઈશું કોઈ. નો 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 નો, પાછળ પાછળ.
સર એવું કંઈક લો જે આપના હાઈ જમ્પર જેવું હોય.
એટલે
જેમ જમ્પ મારવા માટે જોઈએ બેમિસાલ તાકાત અને કમાલની લચક, એક સારા ટીએમટી રીબારમાં હોવી જોઈએ આ બંને ખૂબીઓ એક સાથે.
જેમ કે
ટાટા ટિસ્કોન 550 એસટી. આમાં છે વધુ તાકાત અને લચક. હવે વાવાઝોડું આવે કે ભૂકંપ, ઘરની સુરક્ષા પાકી.
અને આનું સિલેક્શન પણ.
ટાટા ટિસ્કોન 550 એસટી. સમજદાર બનો, બહેતર પસંદ કરો.
બધું ટીપટોપ. માત્ર આ દવા કન્ટિન્યુ કરવાની છે.
થેન્ક યુ ડોક્ટર સાહેબ.
શું એન્જિનિયર સાહેબ. અચ્છા, હું નીકળું છું. નવા ઘર માટે મટીરિયલ ખરીદવું છે.
ટીએમટી રીબાર કયું યુઝ કરશો?
ટીએમટી રીબાર?
જી હા, એક સારો ટીએમટી રીબાર બિલકુલ આ દવાની જેમ હોય છે. જેમ આમાં સોલ્ટ અને મિનરલનું પરફેક્ટ મિક્સ છે, તેમજ એક પરફેક્ટ રીબારની સ્ટીલમાં સિલિકોન અને મેંગેનીઝનું પરફેક્ટ મિક્સ હોય છે.
એવું ટીએમટી રીબાર છે કોઈ?
ટાટા ટિસ્કોન 550 એસટી. એનું પરફેક્ટ મિક્સ એને આપે છે બહેતર તાકાત અને લચક, જે આપણા ઘરને આપે બેમિસાલ સુરક્ષા.
બરાબર છે.
પરફેક્ટ છે.
પરફેક્ટ છે.
ટાટા ટિસ્કોન 550 એસટી. સમજદાર બનો, બહેતર પસંદ કરો. ક્યાં જાઓ છો સવાર સવારમાં?
અરે ચિંટુ એન્જિનિયર, ઘર બની રહ્યો છે ને, ટીએમટી રીબાર્સ લેવા છે.
કયા?
કોઈ પણ સસ્તા વાળા.
અને આ નવો ફોન આ કેવી રીતે લીધો?
આ સ્ટોરેજ, કેમેરા, ડિસ્પ્લે બધું ચેક કરીને લીધો.
અચ્છા, તો ફોન માટે આટલું રિસર્ચ અને ઘર માટે? એટલે ટાટા સ્ટીલ આશિયાના પર રિસર્ચ કરીશ ત્યારે ખબર પડશે કે ટાટા ટિસ્કોન 550 એસડી માં છે બહેતર તાકાત અને લચક, જે આપના ઘરને આપે સુરક્ષા સાથે સેવિંગ્સ પણ. શું થયું?
પહેલા રિસર્ચ કરવું છે ને.
ગુડ વન.
સર
અરે ચિંટુ, તું અહીં?
હમણાં જ આવ્યો દિલ્હીથી.
એમ?
સાંભળ્યું તમે ઘર બનાવી રહ્યા છો?
હા હા, એન્જિનિયરજી અહીં જ તો પાછળ.
અરે વાહ, પણ ટીએમટી રીબાર કયું લીધું તમે?
ટીએમટી રીબાર લઈ લઈશું કોઈ. નો 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 નો, પાછળ પાછળ.
સર એવું કંઈક લો જે આપના હાઈ જમ્પર જેવું હોય.
એટલે
જેમ જમ્પ મારવા માટે જોઈએ બેમિસાલ તાકાત અને કમાલની લચક, એક સારા ટીએમટી રીબારમાં હોવી જોઈએ આ બંને ખૂબીઓ એક સાથે.
જેમ કે
ટાટા ટિસ્કોન 550 એસટી. આમાં છે વધુ તાકાત અને લચક. હવે વાવાઝોડું આવે કે ભૂકંપ, ઘરની સુરક્ષા પાકી.
અને આનું સિલેક્શન પણ.
ટાટા ટિસ્કોન 550 એસટી. સમજદાર બનો, બહેતર પસંદ કરો.
બધું ટીપટોપ. માત્ર આ દવા કન્ટિન્યુ કરવાની છે.
થેન્ક યુ ડોક્ટર સાહેબ.
શું એન્જિનિયર સાહેબ. અચ્છા, હું નીકળું છું. નવા ઘર માટે મટીરિયલ ખરીદવું છે.
ટીએમટી રીબાર કયું યુઝ કરશો?
ટીએમટી રીબાર?
જી હા, એક સારો ટીએમટી રીબાર બિલકુલ આ દવાની જેમ હોય છે. જેમ આમાં સોલ્ટ અને મિનરલનું પરફેક્ટ મિક્સ છે, તેમજ એક પરફેક્ટ રીબારની સ્ટીલમાં સિલિકોન અને મેંગેનીઝનું પરફેક્ટ મિક્સ હોય છે.
એવું ટીએમટી રીબાર છે કોઈ?
ટાટા ટિસ્કોન 550 એસટી. એનું પરફેક્ટ મિક્સ એને આપે છે બહેતર તાકાત અને લચક, જે આપણા ઘરને આપે બેમિસાલ સુરક્ષા.
બરાબર છે.
પરફેક્ટ છે.
પરફેક્ટ છે.
ટાટા ટિસ્કોન 550 એસટી. સમજદાર બનો, બહેતર પસંદ કરો. ક્યાં જાઓ છો સવાર સવારમાં?
અરે ચિંટુ એન્જિનિયર, ઘર બની રહ્યો છે ને, ટીએમટી રીબાર્સ લેવા છે.
કયા?
કોઈ પણ સસ્તા વાળા.
અને આ નવો ફોન આ કેવી રીતે લીધો?
આ સ્ટોરેજ, કેમેરા, ડિસ્પ્લે બધું ચેક કરીને લીધો.
અચ્છા, તો ફોન માટે આટલું રિસર્ચ અને ઘર માટે? એટલે ટાટા સ્ટીલ આશિયાના પર રિસર્ચ કરીશ ત્યારે ખબર પડશે કે ટાટા ટિસ્કોન 550 એસડી માં છે બહેતર તાકાત અને લચક.
ગુડ વન.
સર
અરે ચિંટુ, તું અહીં?
હમણાં જ આવ્યો દિલ્હીથી.
એમ?
સાંભળ્યું તમે ઘર બનાવી રહ્યા છો?
હા હા, એન્જિનિયરજી અહીં જ તો પાછળ.
અરે વાહ, પણ ટીએમટી રીબાર કયું લીધું તમે?
ટીએમટી રીબાર લઈ લઈશું કોઈ? નો 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 નો, પાછળ પાછળ.
સર, એવું કંઈક લો જે આપના હાઈ જમ્પર જેવું હોય.
એટલે
જેમ જમ્પ મારવા માટે જોઈએ બેમિસાલ તાકાત અને કમાલની લચક, એક સારા ટીએમટી રીબારમાં હોવી જોઈએ આ બંને ખૂબીઓ એકસાથે.
જેમ કે
ટાટા ટિસ્કોન 550 SD. આમાં છે વધુ તાકાત અને લચક. હવે વાવાઝોડું આવે કે ભૂકંપ, ઘરની સુરક્ષા પાકી.
અને આનું સિલેક્શન પણ.
ટાટા ટિસ્કોન 550 SD. સમજદાર બનો, બહેતર પસંદ કરો.
બધું ટીપટોપ. માત્ર આ દવા કન્ટિન્યુ કરવાની છે.
થેન્ક યુ ડોક્ટર સાહેબ.
શું એન્જિનિયર સાહેબ. અચ્છા, હું નીકળું છું. નવા ઘર માટે મટીરિયલ ખરીદવું છે.
ટીએમટી રીબાર કયું યુઝ કરશો?
ટીએમટી રીબાર?
જી હા, એક સારો ટીએમટી રીબાર બિલકુલ આ દવાની જેમ હોય છે. જેમ આમાં સોલ્ટ અને મિનરલનું પરફેક્ટ મિક્સ છે, તેમજ એક પરફેક્ટ રીબારની સ્ટીલમાં સિલિકોન અને મેંગેનીઝનું પરફેક્ટ મિક્સ હોય છે.
એવું ટીએમટી રીબાર છે કોઈ?
ટાટા ટિસ્કોન 550 SD. એનું પરફેક્ટ મિક્સ એને આપે છે બહેતર તાકાત અને લચક, જે આપણા ઘરને આપે બેમિસાલ સુરક્ષા.
બરાબર છે.
પરફેક્ટ છે.
પરફેક્ટ છે.
ટાટા ટિસ્કોન 550 SD. સમજદાર બનો, બહેતર પસંદ કરો. ક્યાં જાઓ છો સવાર સવારમાં?
અરે ચિંટુ એન્જિનિયર, ઘર બની રહ્યો છે ને, ટીએમટી રીબાર્સ લેવા છે.
કયા?
કોઈ પણ સસ્તા વાળા.
અને આ નવો ફોન આ કેવી રીતે લીધો?
આ સ્ટોરેજ, કેમેરા, ડિસ્પ્લે બધું ચેક કરીને લીધો.
અચ્છા, તો ફોન માટે આટલું રિસર્ચ અને ઘર માટે? એટલે ટાટા સ્ટીલ આશિયાના પર રિસર્ચ કરીશ ત્યારે ખબર પડશે કે ટાટા ટિસ્કોન 550 SD માં છે બહેતર તાકાત અને લચક, જે આપના ઘરને આપે સુરક્ષા સાથે સેવિંગ્સ પણ. શું થયું?
પહેલા રિસર્ચ કરવું છે ને.
ટાટા ટિસ્કોન 550 SD. સમજદાર બનો, બહેતર પસંદ કરો.
ગુડ વન.
સર.
અરે ચિંટુ, તું અહીં?
હમણાં જ આવ્યો દિલ્હીથી.
એમ?
સાંભળ્યું તમે ઘર બનાવી રહ્યા છો?
હા એન્જિનિયરજી, અહીં જ તો પાછળ.
અરે વાહ, પણ ટીએમટી રીબાર કયું લીધું તમે?
ટીએમટી રીબાર લઈ લઈશું કોઈ? નો 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 નો, પાછળ પાછળ.
સર, એવું કંઈક લો જે આપના હાઈ જમ્પર જેવું હોય.
એટલે
જેમ જમ્પ મારવા માટે જોઈએ બેમિસાલ તાકાત અને કમાલની લચક, એક સારા ટીએમટી રીબારમાં હોવી જોઈએ આ બંને ખૂબીઓ એકસાથે.
જેમ કે
ટાટા ટિસ્કોન 550 SD. આમાં છે વધુ તાકાત અને લચક. હવે વાવાઝોડું આવે કે ભૂકંપ, ઘરની સુરક્ષા પાકી.
અને આનું સિલેક્શન પણ.
ટાટા ટિસ્કોન 550 SD. સમજદાર બનો, બહેતર પસંદ કરો.
બધું ટીપટોપ. માત્ર આ દવા કન્ટિન્યુ કરવાની છે.
થેન્ક યુ ડોક્ટર સાહેબ.
શું એન્જિનિયર સાહેબ. અચ્છા, હું નીકળું છું. નવા ઘર માટે મટીરિયલ ખરીદવું છે.
ટીએમટી રીબાર કયું યુઝ કરશો?
ટીએમટી રીબાર?
જી હા, એક સારો ટીએમટી રીબાર બિલકુલ આ દવાની જેમ હોય છે. જેમ આમાં સોલ્ટ અને મિનરલનું પરફેક્ટ મિક્સ છે, તેમજ એક પરફેક્ટ રીબારની સ્ટીલમાં સિલિકોન અને મેંગેનીઝનું પરફેક્ટ મિક્સ હોય છે.
એવું ટીએમટી રીબાર છે કોઈ?
ટાટા ટિસ્કોન 550 SD. એનું પરફેક્ટ મિક્સ એને આપે છે બહેતર તાકાત અને લચક, જે આપણા ઘરને આપે બેમિસાલ સુરક્ષા.
બરાબર છે.
પરફેક્ટ છે.
પરફેક્ટ છે.
ટાટા ટિસ્કોન 550 SD. સમજદાર બનો, બહેતર પસંદ કરો. ક્યાં જાઓ છો સવાર સવારમાં?
અરે ચિંટુ એન્જિનિયર, ઘર બની રહ્યો છે ને, ટીએમટી રીબાર્સ લેવા છે.
કયા?
કોઈ પણ સસ્તા વાળા.
અને આ નવો ફોન આ કેવી રીતે લીધો?
આ સ્ટોરેજ, કેમેરા, ડિસ્પ્લે બધું ચેક કરીને લીધો.
અચ્છા, તો ફોન માટે આટલું રિસર્ચ અને ઘર માટે? એટલે ટાટા સ્ટીલ આશિયાના પર રિસર્ચ કરીશ ત્યારે ખબર પડશે કે ટાટા ટિસ્કોન 550 SD માં છે બહેતર તાકાત અને લચક, જે આપના ઘરને આપે સુરક્ષા સાથે સેવિંગ્સ પણ. શું થયું?
પહેલા રિસર્ચ કરવું છે ને.
ટાટા ટિસ્કોન 550 SD. સમજદાર બનો, બહેતર પસંદ કરો.
ગુડ વન.
સર.
અરે ચિંટુ, તું અહીં?
હમણાં જ આવ્યો દિલ્હીથી.
એમ?
સાંભળ્યું તમે ઘર બનાવી રહ્યા છો?
હા એન્જિનિયરજી, અહીં જ તો પાછળ.
અરે વાહ, પણ ટીએમટી રીબાર કયું લીધું તમે?
ટીએમટી રીબાર લઈ લઈશું કોઈ? નો 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 નો, પાછળ પાછળ.
સર, એવું કંઈક લો જે આપના હાઈ જમ્પર જેવું હોય.
એટલે
જેમ જમ્પ મારવા માટે જોઈએ બેમિસાલ તાકાત અને કમાલની લચક, એક સારા ટીએમટી રીબારમાં હોવી જોઈએ આ બંને ખૂબીઓ એકસાથે.
જેમ કે
ટાટા ટિસ્કોન 550 SD. આમાં છે વધુ તાકાત અને લચક. હવે વાવાઝોડું આવે કે ભૂકંપ, ઘરની સુરક્ષા પાકી.
અને આનું સિલેક્શન પણ.
ટાટા ટિસ્કોન 550 ST સમજદાર બનો, બહેતર પસંદ કરો.
બધું ટીપટોપ. માત્ર આ દવા કન્ટિન્યુ કરવાની છે.
થેન્ક યુ ડોક્ટર સાહેબ.
શું એન્જિનિયર સાહેબ. અચ્છા, હું નીકળું છું. નવા ઘર માટે મટીરિયલ ખરીદવું છે.
ટીએમટી રીબાર કયું યુઝ કરશો?
ટીએમટી રીબાર?
જી હા, એક સારો ટીએમટી રીબાર બિલકુલ આ દવાની જેમ હોય છે. જેમ આમાં સોલ્ટ અને મિનરલનું પરફેક્ટ મિક્સ છે, તેમજ એક પરફેક્ટ રીબારની સ્ટીલમાં સિલિકોન અને મેંગેનીઝનું પરફેક્ટ મિક્સ હોય છે.
એવું ટીએમટી રીબાર છે કોઈ?
ટાટા ટિસ્કોન 550 ST એનું પરફેક્ટ મિક્સ એને આપે છે બહેતર તાકાત અને લચક, જે આપણા ઘરને આપે બેમિસાલ સુરક્ષા.
બરાબર છે.
પરફેક્ટ છે.
પરફેક્ટ છે.
ટાટા ટિસ્કોન 550 ST સમજદાર બનો, બહેતર પસંદ કરો. ક્યાં જાઓ છો સવાર સવારમાં?
અરે ચિંટુ એન્જિનિયર, ઘર બની રહ્યો છે ને, ટીએમટી રીબાર્સ લેવા છે.
કયા?
કોઈ પણ સસ્તાવાળા.
અને આ નવો ફોન આ કેવી રીતે લીધો?
આ સ્ટોરેજ, કેમેરા, ડિસ્પ્લે બધું ચેક કરીને લીધો.
અચ્છા, તો ફોન માટે આટલું રિસર્ચ અને ઘર માટે? એટલે ટાટા સ્ટીલ આશિયાના પર રિસર્ચ કરીશ ત્યારે ખબર પડશે કે ટાટા ટિસ્કોન 550 SD માં છે બહેતર તાકાત અને લચક, જે આપના ઘરને આપે સુરક્ષા સાથે સેવિંગ્સ પણ. શું થયું?
પહેલા રિસર્ચ કરવું છે ને.
ટાટા ટિસ્કોન 550 ST સમજદાર બનો, બહેતર પસંદ કરો.
ગુડ વન.
સર.
અરે ચિંટુ, તું અહીં?
હમણાં જ આવ્યો દિલ્હીથી.
એમ?
સાંભળ્યું તમે ઘર બનાવી રહ્યા છો?
હા, એન્જિનિયરજી અહીં જ તો પાછળ.
અરે વાહ, પણ ટીએમટી રીબાર કયું લીધું તમે?
ટીએમટી રીબાર લઈ લઈશું કોઈ? નો 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 નો, પાછળ પાછળ.
સર, એવું કંઈક લો જે આપના હાઈ જમ્પર જેવું હોય.
એટલે?
જેમ જમ્પ મારવા માટે જોઈએ બેમિસાલ તાકાત અને કમાલની લચક, એક સારા ટીએમટી રીબારમાં હોવી જોઈએ આ બંને ખૂબીઓ એક સાથે.
જેમ કે?
ટાટા ટિસ્કોન 550 ST આમાં છે વધુ તાકાત અને લચક. હવે વાવાઝોડું આવે કે ભૂકંપ, ઘરની સુરક્ષા પાકી.
અને આનું સિલેક્શન પણ.
ટાટા ટિસ્કોન 550 ST સમજદાર બનો, બહેતર પસંદ કરો.
બધું ટીપટોપ. માત્ર આ દવા કન્ટિન્યુ કરવાની છે.
થેન્ક યુ ડોક્ટર સાહેબ.
શું એન્જિનિયર સાહેબ. અચ્છા, હું નીકળું છું. નવા ઘર માટે મટીરિયલ ખરીદવું છે.
ટીએમટી રીબાર કયું યુઝ કરશો?
ટીએમટી રીબાર?
જી હા, એક સારો ટીએમટી રીબાર બિલકુલ આ દવાની જેમ હોય છે. જેમ આમાં સોલ્ટ અને મિનરલનું પરફેક્ટ મિક્સ છે, તેમજ એક પરફેક્ટ રીબારની સ્ટીલમાં સિલિકોન અને મેંગેનીઝનું પરફેક્ટ મિક્સ હોય છે.
એવું ટીએમટી રીબાર છે કોઈ?
ટાટા ટિસ્કોન 550 ST એનું પરફેક્ટ મિક્સ એને આપે છે બહેતર તાકાત અને લચક, જે આપણા ઘરને આપે બેમિસાલ સુરક્ષા.
બરાબર છે.
પરફેક્ટ છે.
પરફેક્ટ છે.
ટાટા ટિસ્કોન 550 ST સમજદાર બનો, બહેતર પસંદ કરો. ક્યાં જાઓ છો સવાર સવારમાં?
અરે ચિંટુ એન્જિનિયર, ઘર બની રહ્યો છે ને, ટીએમટી રીબાર્સ લેવા છે.
કયા?
કોઈ પણ સસ્તાવાળા.
અને આ નવો ફોન આ કેવી રીતે લીધો?
આ સ્ટોરેજ, કેમેરા, ડિસ્પ્લે બધું ચેક કરીને લીધો.
અચ્છા, તો ફોન માટે આટલું રિસર્ચ અને ઘર માટે? એટલે ટાટા સ્ટીલ આશિયાના પર રિસર્ચ કરીશ ત્યારે ખબર પડશે કે ટાટા ટિસ્કોન 550 SD માં છે બહેતર તાકાત અને લચક, જે આપના ઘરને આપે સુરક્ષા સાથે સેવિંગ્સ પણ. શું થયું?
પહેલા રિસર્ચ કરવું છે ને.
ટાટા ટિસ્કોન 550 ST સમજદાર બનો, બહેતર પસંદ કરો.
ગુડ વન.
સર.
અરે ચિંટુ, તું અહીં?
હમણાં જ આવ્યો દિલ્હીથી.
એમ?
સાંભળ્યું તમે ઘર બનાવી રહ્યા છો?
હા, એન્જિનિયરજી અહીં જ તો પાછળ.
અરે વાહ, પણ ટીએમટી રીબાર કયું લીધું તમે?
ટીએમટી રીબાર લઈ લઈશું કોઈ? નો 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 નો, પાછળ પાછળ.
સર, એવું કંઈક લો જે આપના હાઈ જમ્પર જેવું હોય.
એટલે?
જેમ જમ્પ મારવા માટે જોઈએ બેમિસાલ તાકાત અને કમાલની લચક, એક સારા ટીએમટી રીબારમાં હોવી જોઈએ આ બંને ખૂબીઓ એક સાથે.
જેમ કે?
ટાટા ટિસ્કોન 550 ST આમાં છે વધુ તાકાત અને લચક. હવે વાવાઝોડું આવે કે ભૂકંપ, ઘરની સુરક્ષા પાકી.
અને આનું સિલેક્શન પણ.
ટાટા ટિસ્કોન 550 ST સમજદાર બનો, બહેતર પસંદ કરો.
બધું ટીપટોપ. માત્ર આ દવા કન્ટિન્યુ કરવાની છે.
થેન્ક યુ ડોક્ટર સાહેબ.
શું એન્જિનિયર સાહેબ. અચ્છા, હું નીકળું છું. નવા ઘર માટે મટીરિયલ ખરીદવું છે.
ટીએમટી રીબાર કયું યુઝ કરશો?
ટીએમટી રીબાર?
જી હા, એક સારો ટીએમટી રીબાર બિલકુલ આ દવાની જેમ હોય છે. જેમ આમાં સોલ્ટ અને મિનરલનું પરફેક્ટ મિક્સ છે, તેમજ એક પરફેક્ટ રીબારની સ્ટીલમાં સિલિકોન અને મેંગેનીઝનું પરફેક્ટ મિક્સ હોય છે.
એવું ટીએમટી રીબાર છે કોઈ?
ટાટા ટિસ્કોન 550 ST એનું પરફેક્ટ મિક્સ એને આપે છે બહેતર તાકાત અને લચક, જે આપણા ઘરને આપે બેમિસાલ સુરક્ષા.
બરાબર છે.
પરફેક્ટ છે.
પરફેક્ટ છે.
ટાટા ટિસ્કોન 550 ST, સમજદાર બનો, બહેતર પસંદ કરો. ક્યાં જાઓ છો સવારમાં?
અરે ચિંટુ એન્જિનિયર, ઘર બની રહ્યો છે ને, ટીએમટી રીબાર્સ લેવા છે.
કયા?
કોઈ પણ સસ્તાવાળા.
અને આ નવો ફોન આ કેવી રીતે લીધો?
આ સ્ટોરેજ, કેમેરા, ડિસ્પ્લે બધું ચેક કરીને લીધો.
અચ્છા, તો ફોન માટે આટલું રિસર્ચ અને ઘર માટે? એટલે ટાટા સ્ટીલ આશિયાના પર રિસર્ચ કરીશ ત્યારે ખબર પડશે કે ટાટા ટિસ્કોન 550 SD માં છે બહેતર તાકાત અને લચક, જે આપના ઘરને આપે સુરક્ષા સાથે સેવિંગ્સ પણ. શું થયું?
પહેલા રિસર્ચ કરવું છે ને.
ટાટા ટિસ્કોન 550 SD, સમજદાર બનો, બહેતર પસંદ કરો.
ગુડ વન
સર.
અરે ચિંટુ, તું અહીં?
હમણાં જ આવ્યો દિલ્હીથી.
એમ?
સાંભળ્યું તમે ઘર બનાવી રહ્યા છો?
હા એન્જિનિયરજી, અહીં જ તો પાછળ.
અરે વાહ, પણ ટીએમટી રીબાર કયું લીધું તમે?
ટીએમટી રીબાર લઈ લઈશું કોઈ? નો 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 નો, પાછળ પાછળ.
સર, એવું કંઈક લો જે આપના હાઈ જમ્પર જેવું હોય.
એટલે?
જેમ જમ્પ મારવા માટે જોઈએ બેમિસાલ તાકાત અને કમાલની લચક, એક સારા ટીએમટી રીબારમાં હોવી જોઈએ આ બંને ખૂબીઓ એક સાથે.
જેમ કે?
ટાટા ટિસ્કોન 550 SD, આમાં છે વધુ તાકાત અને લચક. હવે વાવાઝોડું આવે કે ભૂકંપ, ઘરની સુરક્ષા પાકી.
અને આનું સિલેક્શન પણ.
ટાટા ટિસ્કોન 550 SD, સમજદાર બનો, બહેતર પસંદ કરો.
બધું ટીપટોપ. માત્ર આ દવા કન્ટિન્યુ કરવાની છે.
થેન્ક યુ ડોક્ટર સાહેબ.
શું એન્જિનિયર સાહેબ. અચ્છા, હું નીકળું છું. નવા ઘર માટે મટીરિયલ ખરીદવું છે.
ટીએમટી રીબાર કયું યુઝ કરશો?
ટીએમટી રીબાર?
જી હા, એક સારો ટીએમટી રીબાર બિલકુલ આ દવાની જેમ હોય છે. જેમ આમાં સોલ્ટ અને મિનરલનું પરફેક્ટ મિક્સ છે, તેમજ એક પરફેક્ટ રીબારની સ્ટીલમાં સિલિકોન અને મેંગેનીઝનું પરફેક્ટ મિક્સ હોય છે.
એવું ટીએમટી રીબાર છે કોઈ?
ટાટા ટિસ્કોન 550 ST એનું પરફેક્ટ મિક્સ એને આપે છે બહેતર તાકાત અને લચક, જે આપણા ઘરને આપે બેમિસાલ સુરક્ષા.
બરાબર છે.
પરફેક્ટ છે.
પરફેક્ટ છે.
ટાટા ટિસ્કોન 550 ST, સમજદાર બનો, બહેતર પસંદ કરો. ક્યાં જાઓ છો સવારમાં?
અરે ચિંટુ એન્જિનિયર, ઘર બની રહ્યો છે ને, ટીએમટી રીબાર્સ લેવા છે.
કયા?
કોઈ પણ સસ્તાવાળા.
અને આ નવો ફોન આ કેવી રીતે લીધો?
આ સ્ટોરેજ, કેમેરા, ડિસ્પ્લે બધું ચેક કરીને લીધો.
અચ્છા, તો ફોન માટે આટલું રિસર્ચ અને ઘર માટે? એટલે ટાટા સ્ટીલ આશિયાના પર રિસર્ચ કરીશ ત્યારે ખબર પડશે કે ટાટા ટિસ્કોન 550 SD માં છે બહેતર તાકાત અને લચક, જે આપના ઘરને આપે સુરક્ષા સાથે સેવિંગ્સ પણ. શું થયું?
પહેલા રિસર્ચ કરવું છે ને.
ટાટા ટિસ્કોન 550 ST, સમજદાર બનો, બહેતર પસંદ કરો.
ગુડ વન
સર.
અરે ચિંટુ, તું અહીં?
હમણાં જ આવ્યો દિલ્હીથી.
એમ?
સાંભળ્યું તમે ઘર બનાવી રહ્યા છો?
હા એન્જિનિયરજી, અહીં જ તો પાછળ.
અરે વાહ, પણ ટીએમટી રીબાર કયું લીધું તમે?
ટીએમટી રીબાર લઈ લઈશું કોઈ? નો 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 નો, પાછળ પાછળ.
સર, એવું કંઈક લો જે આપના હાઈ જમ્પર જેવું હોય.
એટલે?
જેમ જમ્પ મારવા માટે જોઈએ બેમિસાલ તાકાત અને કમાલની લચક, એક સારા ટીએમટી રીબારમાં હોવી જોઈએ આ બંને ખૂબીઓ એક સાથે.
જેમ કે?
ટાટા ટિસ્કોન 550 SD, આમાં છે વધુ તાકાત અને લચક. હવે વાવાઝોડું આવે કે ભૂકંપ, ઘરની સુરક્ષા પાકી.
અને આનું સિલેક્શન પણ.
ટાટા ટિસ્કોન 550 ST, સમજદાર બનો, બહેતર પસંદ કરો.
બધું ટીપટોપ. માત્ર આ દવા કન્ટિન્યુ કરવાની છે.
થેન્ક યુ ડોક્ટર સાહેબ.
શું એન્જિનિયર સાહેબ. અચ્છા, હું નીકળું છું. નવા ઘર માટે મટીરિયલ ખરીદવું છે.
ટીએમટી રીબાર કયું યુઝ કરશો?
ટીએમટી રીબાર?
જી હા, એક સારો ટીએમટી રીબાર બિલકુલ આ દવાની જેમ હોય છે. જેમ આમાં સોલ્ટ અને મિનરલનું પરફેક્ટ મિક્સ છે, તેમજ એક પરફેક્ટ રીબારની સ્ટીલમાં સિલિકોન અને મેંગેનીઝનું પરફેક્ટ મિક્સ હોય છે.
એવું ટીએમટી રીબાર છે કોઈ?
ટાટા ટિસ્કોન 550 ST એનું પરફેક્ટ મિક્સ એને આપે છે બહેતર તાકાત અને લચક, જે આપણા ઘરને આપે બેમિસાલ સુરક્ષા.
બરાબર છે.
પરફેક્ટ છે.
પરફેક્ટ છે.
टाटा टिस्कॉन 550 ST समझदार बनो बेहतर पसंद करो ક્યાં જાઓ છો સવાર સવારમાં
અરે ચિંટુ એન્જિનિયર ઘર બની રહ્યો છે ને ટીએમટી રિબાર્સ લેવા છે
કયા
કોઈ પણ સસ્તા વાળા
અને આ નવો ફોન આ કેવી રીતે લીધો
આ સ્ટોરેજ કેમેરા ડિસ્પ્લે બધું ચેક કરીને લીધો
અચ્છા તો ફોન માટે આટલું રિસર્ચ અને ઘર માટે એટલે ટાટા સ્ટીલ આશિયાના પર રિસર્ચ કરીશ ત્યારે ખબર પડશે કે ટાટા ટિસ્કોન 550 SD માં છે બહેતર તાકાત અને લચક જે આપના ઘરને આપે સુરક્ષા સાથે સેવિંગ્સ પણ શું થયું
પહેલા રિસર્ચ કરવું છે ને
टाटा टिस्कॉन 550 ST समझदार बनो बेहतर पसंद करो
ગુડ વન
સર
અરે ચિંટુ તું અહીં
હમણાં જ આવ્યો દિલ્હીથી
એમ
સાંભળ્યું તમે ઘર બનાવી રહ્યા છો
હા એન્જિનિયરજી અહીં જ તો પાછળ
અરે વાહ પણ ટીએમટી રીબાર કયું લીધું તમે
ટીએમટી રીબાર લઈ લઈશું કોઈ નો 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 પાછળ પાછળ
સર એવું કંઈક લો જે આપના હાઈ જમ્પર જેવું હોય
એટલે
જેમ જમ્પ મારવા માટે જોઈએ બેમિસાલ તાકાત અને કમાલની લચક એક સારા ટીએમટી રીબારમાં હોવી જોઈએ આ બંને ખૂબીઓ એકસાથે
જેમ કે
ટાટા ટિસ્કોન 550 ST આમાં છે વધુ તાકાત અને લચક હવે વાવાઝોડું આવે કે ભૂકંપ ઘરની સુરક્ષા પાકી
અને આનું સિલેક્શન પણ
ટાટા ટિસ્કોન 550 ST સમજદાર બનો બેહતર પસંદ કરો
બધું ટીપ ટોપ માત્ર આ દવા કન્ટિન્યુ કરવાની છે
થેન્ક યુ ડોક્ટર સાહેબ
શું એન્જિનિયર સાહેબ અચ્છા હું નીકળું છું નવા ઘર માટે મટીરિયલ ખરીદવું છે
ટીએમટી રીબાર કયું યુઝ કરશો
ટીએમટી રીબાર
જી હા એક સારો ટીએમટી રીબાર બિલકુલ આ દવાની જેમ હોય છે જેમ આમાં સોલ્ટ અને મિનરલનું પરફેક્ટ મિક્સ છે તેમજ એક પરફેક્ટ રીબારની સ્ટીલમાં સિલિકોન અને મેંગેનીઝનું પરફેક્ટ મિક્સ હોય છે
એવું ટીએમટી રીબાર છે કોઈ
ટાટા ટિસ્કોન 550 ST એનું પરફેક્ટ મિક્સ એને આપે છે બહેતર તાકાત અને લચક જે આપણા ઘરને આપે બેમિસાલ સુરક્ષા
બરાબર છે
પરફેક્ટ છે
પરફેક્ટ છે
ટાટા ટિસ્કોન 550 ST સમજદાર બનો બેહતર પસંદ કરો ક્યાં જાઓ છો સવાર સવારમાં
અરે ચિંટુ એન્જિનિયર ઘર બની રહ્યો છે ને ટીએમટી રિબાર્સ લેવા છે
કયા
કોઈ પણ સસ્તા વાળા
અને આ નવો ફોન આ કેવી રીતે લીધો
આ સ્ટોરેજ કેમેરા ડિસ્પ્લે બધું ચેક કરીને લીધો
અચ્છા તો ફોન માટે આટલું રિસર્ચ અને ઘર માટે એટલે ટાટા સ્ટીલ આશિયાના પર રિસર્ચ કરીશ ત્યારે ખબર પડશે કે ટાટા ટિસ્કોન 550 SD માં છે બહેતર તાકાત અને લચક જે આપના ઘરને આપે સુરક્ષા સાથે સેવિંગ્સ પણ શું થયું
પહેલા રિસર્ચ કરવું છે ને
टाटा टिस्कॉन 550 ST समझदार बनो बेहतर पसंद करो
ગુડ વન
સર
અરે ચિંટુ તું અહીં
હમણાં જ આવ્યો દિલ્હીથી
એમ
સાંભળ્યું તમે ઘર બનાવી રહ્યા છો
હા એન્જિનિયરજી અહીં જ તો પાછળ
અરે વાહ પણ ટીએમટી રીબાર કયું લીધું તમે
ટીએમટી રીબાર લઈ લઈશું કોઈ નો 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 પાછળ પાછળ
સર એવું કંઈક લો જે આપના હાઈ જમ્પર જેવું હોય
એટલે
જેમ જમ્પ મારવા માટે જોઈએ બેમિસાલ તાકાત અને કમાલની લચક એક સારા ટીએમટી રીબારમાં હોવી જોઈએ આ બંને ખૂબીઓ એકસાથે
જેમ કે
ટાટા ટિસ્કોન 550 ST આમાં છે વધુ તાકાત અને લચક હવે વાવાઝોડું આવે કે ભૂકંપ ઘરની સુરક્ષા પાકી
અને આનું સિલેક્શન પણ
ટાટા ટિસ્કોન 550 ST સમજદાર બનો બેહતર પસંદ કરો
બધું ટીપ ટોપ માત્ર આ દવા કન્ટિન્યુ કરવાની છે
થેન્ક યુ ડોક્ટર સાહેબ
શું એન્જિનિયર સાહેબ અચ્છા હું નીકળું છું નવા ઘર માટે મટીરિયલ ખરીદવું છે
ટીએમટી રીબાર કયું યુઝ કરશો
ટીએમટી રીબાર
જી હા એક સારો ટીએમટી રીબાર બિલકુલ આ દવાની જેમ હોય છે જેમ આમાં સોલ્ટ અને મિનરલનું પરફેક્ટ મિક્સ છે તેમજ એક પરફેક્ટ રીબારની સ્ટીલમાં સિલિકોન અને મેંગેનીઝનું પરફેક્ટ મિક્સ હોય છે
એવું ટીએમટી રીબાર છે કોઈ
ટાટા ટિસ્કોન 550 ST એનું પરફેક્ટ મિક્સ એને આપે છે બહેતર તાકાત અને લચક જે આપણા ઘરને આપે બેમિસાલ સુરક્ષા
બરાબર છે
પરફેક્ટ છે
પરફેક્ટ છે
ટાટા ટિસ્કોન 550 ST સમજદાર બનો બેહતર પસંદ કરો ક્યાં જાઓ છો સવાર સવારમાં
અરે ચિંટુ એન્જિનિયર ઘર બની રહ્યો છે ને ટીએમટી રિબાર્સ લેવા છે
કયા
કોઈ પણ સસ્તા વાળા
અને આ નવો ફોન આ કેવી રીતે લીધો
આ સ્ટોરેજ કેમેરા ડિસ્પ્લે બધું ચેક કરીને લીધો
અચ્છા તો ફોન માટે આટલું રિસર્ચ અને ઘર માટે
એટલે
એટલે ટાટા સ્ટીલ આશિયાના પર રિસર્ચ કરીશ ત્યારે ખબર પડશે કે ટાટા ટિસ્કોન 550 એસડીમાં છે બહેતર તાકાત અને લચક, જે આપના ઘરને આપે સુરક્ષા સાથે સેવિંગ્સ પણ. શું થયું?
પહેલા રિસર્ચ કરવું છે ને.
ટાટા ટિસ્કોન 550 એસડી, સમજદાર બનો, બહેતર પસંદ કરો.
ગુડ વન.
સર,
અરે ચિંટુ, તું અહીં?
હમણાં જ આવ્યો દિલ્હીથી.
એમ?
સાંભળ્યું તમે ઘર બનાવી રહ્યા છો?
હા હા, એન્જિનિયરજી અહીં જ તો પાછળ.
અરે વાહ, પણ ટીએમટી રીબાર કયું લીધું તમે?
ટીએમટી રીબાર લઈ લઈશું કોઈ? નો 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 નો, પાછળ પાછળ.
સર, એવું કંઈક લો જે આપના હાઈ જમ્પર જેવું હોય.
એટલે
જેમ જમ્પ મારવા માટે જોઈએ બેમિસાલ તાકાત અને કમાલની લચક, એક સારા ટીએમટી રીબારમાં હોવી જોઈએ આ બંને ખૂબીઓ એક સાથે.
જેમ કે
ટાટા ટિસ્કોન 550 એસડી, આમાં છે વધુ તાકાત અને લચક. હવે વાવાઝોડું આવે કે ભૂકંપ, ઘરની સુરક્ષા પાકી.
અને આનું સિલેક્શન પણ.
ટાટા ટિસ્કોન 550 એસડી, સમજદાર બનો, બહેતર પસંદ કરો.
બધું ટીપટોપ. માત્ર આ દવા કન્ટિન્યુ કરવાની છે.
થેન્ક યુ ડોક્ટર સાહેબ.
શું એન્જિનિયર સાહેબ. અચ્છા, હું નીકળું છું. નવા ઘર માટે મટીરિયલ ખરીદવું છે.
ટીએમટી રીબાર કયું યુઝ કરશો?
ટીએમટી રીબાર?
જી હા, એક સારો ટીએમટી રીબાર બિલકુલ આ દવાની જેમ હોય છે. જેમ આમાં સોલ્ટ અને મિનરલનું પરફેક્ટ મિક્સ છે, તેમજ એક પરફેક્ટ રીબારની સ્ટીલમાં સિલિકોન અને મેંગેનીઝનું પરફેક્ટ મિક્સ હોય છે.
એવું ટીએમટી રીબાર છે કોઈ?
ટાટા ટિસ્કોન 550 એસડી, એનું પરફેક્ટ મિક્સ એને આપે છે બહેતર તાકાત અને લચક, જે આપણા ઘરને આપે બેમિસાલ સુરક્ષા.
બરાબર છે.
પરફેક્ટ છે.
પરફેક્ટ છે.
ટાટા ટિસ્કોન 550 એસડી, સમજદાર બનો, બહેતર પસંદ કરો. ક્યાં જાઓ છો સવાર સવારમાં?
અરે ચિંટુ એન્જિનિયર, ઘર બની રહ્યો છે ને, ટીએમટી રીબાર્સ લેવા છે.
કયા?
કોઈ પણ સસ્તાવાળા.
અને આ નવો ફોન આ કેવી રીતે લીધો?
આ સ્ટોરેજ, કેમેરા, ડિસ્પ્લે બધું ચેક કરીને લીધો.
અચ્છા, તો ફોન માટે આટલું રિસર્ચ અને ઘર માટે? એટલે ટાટા સ્ટીલ આશિયાના પર રિસર્ચ કરીશ ત્યારે ખબર પડશે કે ટાટા ટિસ્કોન 550 એસડીમાં છે બહેતર તાકાત અને લચક, જે આપના ઘરને આપે સુરક્ષા સાથે સેવિંગ્સ પણ. શું થયું?
પહેલા રિસર્ચ કરવું છે ને.
ટાટા ટિસ્કોન 550 એસડી, સમજદાર બનો, બહેતર પસંદ કરો.
ગુડ વન.
સર,
અરે ચિંટુ, તું અહીં?
હમણાં જ આવ્યો દિલ્હીથી.
એમ?
સાંભળ્યું તમે ઘર બનાવી રહ્યા છો?
હા હા, એન્જિનિયરજી અહીં જ તો પાછળ.
અરે વાહ, પણ ટીએમટી રીબાર કયું લીધું તમે?
ટીએમટી રીબાર લઈ લઈશું કોઈ? નો 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 નો, પાછળ પાછળ.
સર, એવું કંઈક લો જે આપના હાઈ જમ્પર જેવું હોય.
એટલે
જેમ જમ્પ મારવા માટે જોઈએ બેમિસાલ તાકાત અને કમાલની લચક, એક સારા ટીએમટી રીબારમાં હોવી જોઈએ આ બંને ખૂબીઓ એક સાથે.
જેમ કે
ટાટા ટિસ્કોન 550 એસડી, આમાં છે વધુ તાકાત અને લચક. હવે વાવાઝોડું આવે કે ભૂકંપ, ઘરની સુરક્ષા પાકી.
અને આનું સિલેક્શન પણ.
ટાટા ટિસ્કોન 550 એસડી, સમજદાર બનો, બહેતર પસંદ કરો.
બધું ટીપટોપ. માત્ર આ દવા કન્ટિન્યુ કરવાની છે.
થેન્ક યુ ડોક્ટર સાહેબ.
શું એન્જિનિયર સાહેબ. અચ્છા, હું નીકળું છું. નવા ઘર માટે મટીરિયલ ખરીદવું છે.
ટીએમટી રીબાર કયું યુઝ કરશો?
ટીએમટી રીબાર?
જી હા, એક સારો ટીએમટી રીબાર બિલકુલ આ દવાની જેમ હોય છે. જેમ આમાં સોલ્ટ અને મિનરલનું પરફેક્ટ મિક્સ છે, તેમજ એક પરફેક્ટ રીબારની સ્ટીલમાં સિલિકોન અને મેંગેનીઝનું પરફેક્ટ મિક્સ હોય છે.
એવું ટીએમટી રીબાર છે કોઈ?
ટાટા ટિસ્કોન 550 એસડી, એનું પરફેક્ટ મિક્સ એને આપે છે બહેતર તાકાત અને લચક, જે આપણા ઘરને આપે બેમિસાલ સુરક્ષા.
બરાબર છે.
પરફેક્ટ છે.
પરફેક્ટ છે.
ટાટા ટિસ્કોન 550 એસડી, સમજદાર બનો, બહેતર પસંદ કરો. ક્યાં જાઓ છો સવાર સવારમાં?
અરે ચિંટુ એન્જિનિયર, ઘર બની રહ્યો છે ને, ટીએમટી રીબાર્સ લેવા છે.
કયા?
કોઈ પણ સસ્તાવાળા.
અને આ નવો ફોન આ કેવી રીતે લીધો?
આ સ્ટોરેજ, કેમેરા, ડિસ્પ્લે બધું ચેક કરીને લીધો.
અચ્છા, તો ફોન માટે આટલું રિસર્ચ અને ઘર માટે? એટલે ટાટા સ્ટીલ આશિયાના પર રિસર્ચ કરીશ ત્યારે ખબર પડશે કે ટાટા ટિસ્કોન 550 એસડીમાં છે બહેતર તાકાત અને લચક, જે આપના ઘરને આપે સુરક્ષા સાથે સેવિંગ્સ પણ. શું થયું?
પહેલા રિસર્ચ કરવું છે ને.
ટાટા ટિસ્કોન 550 એસડી, સમજદાર બનો, બહેતર પસંદ કરો.
ગુડ વન.
સર
અરે ચિંટુ તું અહીં
હમણાં જ આવ્યો દિલ્હીથી.
એમ
સાંભળ્યું તમે ઘર બનાવી રહ્યા છો?
હા એન્જિનિયરજી અહીં જ તો પાછળ
અરે વાહ, પણ ટીએમટી રીબાર કયું લીધું તમે?
ટીએમટી રીબાર લઈ લઈશું કોઈ નો 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 પાછળ પાછળ
સર એવું કંઈક લો જે આપના હાઈ જમ્પર જેવું હોય.
એટલે
જેમ જમ્પ મારવા માટે જોઈએ બેમિસાલ તાકાત અને કમાલની લચક, એક સારા ટીએમટી રીબારમાં હોવી જોઈએ આ બંને ખૂબીઓ એક સાથે.
જેમ કે
ટાટા ટિસ્કોન 550 SD. આમાં છે વધુ તાકાત અને લચક. હવે વાવાઝોડું આવે કે ભૂકંપ, ઘરની સુરક્ષા પાકી.
અને આનું સિલેક્શન પણ
ટાટા ટિસ્કોન 550 SD. સમજદાર બનો, બહેતર પસંદ કરો.
બધું ટીપટોપ. માત્ર આ દવા કન્ટિન્યુ કરવાની છે.
થેન્ક યુ ડોક્ટર સાહેબ.
શું એન્જિનિયર સાહેબ. અચ્છા હું નીકળું છું, નવા ઘર માટે મટીરિયલ ખરીદવું છે.
ટીએમટી રીબાર કયું યુઝ કરશો?
ટીએમટી રીબાર?
જી હા, એક સારો ટીએમટી રીબાર બિલકુલ આ દવાની જેમ હોય છે. જેમ આમાં સોલ્ટ અને મિનરલનું પરફેક્ટ મિક્સ છે, તેમજ એક પરફેક્ટ રીબારની સ્ટીલમાં સિલિકોન અને મેંગેનીઝનું પરફેક્ટ મિક્સ હોય છે.
એવું ટીએમટી રીબાર છે કોઈ?
ટાટા ટિસ્કોન 550 SD. એનું પરફેક્ટ મિક્સ એને આપે છે બહેતર તાકાત અને લચક, જે આપણા ઘરને આપે બેમિસાલ સુરક્ષા.
બરાબર છે.
પરફેક્ટ છે.
પરફેક્ટ છે.
ટાટા ટિસ્કોન 550 SD. સમજદાર બનો, બહેતર પસંદ કરો. ક્યાં જાઓ છો સવારમાં?
અરે ચિંટુ એન્જિનિયર ઘર બની રહ્યો છે ને, ટીએમટી રીબાર્સ લેવા છે.
કયા?
કોઈ પણ સસ્તા વાળા.
અને આ નવો ફોન આ કેવી રીતે લીધો?
આ સ્ટોરેજ, કેમેરા, ડિસ્પ્લે બધું ચેક કરીને લીધો.
અચ્છા, તો ફોન માટે આટલું રિસર્ચ અને ઘર માટે? એટલે ટાટા સ્ટીલ આશિયાના પર રિસર્ચ કરીશ ત્યારે ખબર પડશે કે ટાટા ટિસ્કોન 550 SD માં છે બહેતર તાકાત અને લચક, જે આપના ઘરને આપે સુરક્ષા સાથે સેવિંગ્સ પણ. શું થયું?
પહેલા રિસર્ચ કરવું છે ને.
ટાટા ટિસ્કોન 550 SD. સમજદાર બનો, બહેતર પસંદ કરો.
ગુડ વન
સર
અરે ચિંટુ તું અહીં
હમણાં જ આવ્યો દિલ્હીથી.
એમ
સાંભળ્યું તમે ઘર બનાવી રહ્યા છો?
હા એન્જિનિયરજી અહીં જ તો પાછળ
અરે વાહ, પણ ટીએમટી રીબાર કયું લીધું તમે?
ટીએમટી રીબાર લઈ લઈશું કોઈ નો 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 પાછળ પાછળ
સર એવું કંઈક લો જે આપના હાઈ જમ્પર જેવું હોય.
એટલે
જેમ જમ્પ મારવા માટે જોઈએ બેમિસાલ તાકાત અને કમાલની લચક, એક સારા ટીએમટી રીબારમાં હોવી જોઈએ આ બંને ખૂબીઓ એક સાથે.
જેમ કે
ટાટા ટિસ્કોન 550 SD. આમાં છે વધુ તાકાત અને લચક. હવે વાવાઝોડું આવે કે ભૂકંપ, ઘરની સુરક્ષા પાકી.
અને આનું સિલેક્શન પણ
ટાટા ટિસ્કોન 550 SD.
All
સમજદાર
are
બનો,
requested to
બહેતર
take
પસંદ
their
કરો.
seats. We are starting the sessions. All are requested to
tip-top.
take the seats.
માત્ર આ દવા કન્ટિન્યુ કરવાની છે.
થેન્ક યુ ડોક્ટર સાહેબ.
શું એન્જિનિયર સાહેબ. અચ્છા હું નીકળું છું, નવા ઘર માટે મટીરિયલ ખરીદવું છે.
ટીએમટી રીબાર કયું યુઝ કરશો?
ટીએમટી રીબાર?
જી હા, એક સારો ટીએમટી રીબાર બિલકુલ આ દવાની જેમ હોય છે. જેમ આમાં સોલ્ટ અને મિનરલનું પરફેક્ટ મિક્સ છે, તેમજ એક પરફેક્ટ રીબારની સ્ટીલમાં સિલિકોન અને મેંગેનીઝનું પરફેક્ટ મિક્સ હોય છે.
એવું ટીએમટી રીબાર છે કોઈ?
ટાટા ટિસ્કોન 550 SD. એનું પરફેક્ટ મિક્સ એને આપે છે બહેતર તાકાત અને લચક, જે આપણા ઘરને આપે બેમિસાલ સુરક્ષા.
બરાબર છે.
પરફેક્ટ છે.
પરફેક્ટ છે.
ટાટા ટિસ્કોન 550 SD. સમજદાર બનો, બહેતર પસંદ કરો. ક્યાં જાઓ છો સવારમાં?
અરે ચિંટુ એન્જિનિયર ઘર બની રહ્યો છે ને, ટીએમટી રીબાર્સ લેવા છે.
કયા?
કોઈ પણ સસ્તા વાળા.
અને આ નવો ફોન આ કેવી રીતે લીધો?
આ સ્ટોરેજ, કેમેરા, ડિસ્પ્લે બધું ચેક કરીને લીધો.
અચ્છા, તો ફોન માટે આટલું રિસર્ચ અને ઘર માટે? એટલે ટાટા સ્ટીલ આશિયાના પર રિસર્ચ કરીશ ત્યારે ખબર પડશે કે ટાટા ટિસ્કોન 550 SD માં છે બહેતર તાકાત અને લચક, જે આપના ઘરને આપે સુરક્ષા સાથે સેવિંગ્સ પણ. શું થયું?
પહેલા રિસર્ચ કરવું છે ને.
ટાટા ટિસ્કોન 550 SD. સમજદાર બનો, બહેતર પસંદ કરો.
ગુડ વન
સર
અરે ચિંટુ તું અહીં
હમણાં જ આવ્યો દિલ્હીથી.
એમ
સાંભળ્યું તમે ઘર બનાવી રહ્યા છો?
હા એન્જિનિયરજી અહીં જ તો પાછળ
અરે વાહ, પણ ટીએમટી રીબાર કયું લીધું તમે?
ટીએમટી રીબાર લઈ લઈશું કોઈ નો 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 પાછળ પાછળ
સર એવું કંઈક લો જે આપના હાઈ જમ્પર જેવું હોય.
એટલે
જેમ જમ્પ મારવા માટે જોઈએ બેમિસાલ તાકાત અને કમાલની લચક, એક સારા TMT રીબારમાં હોવી જોઈએ આ બંને ખૂબીઓ એકસાથે.
જેમ કે
ટાટા ટિસ્કોન 550 SD. આમાં છે વધુ તાકાત અને લચક. હવે વાવાઝોડું આવે કે ભૂકંપ, ઘરની સુરક્ષા પાકી.
અને આનું સિલેક્શન પણ.
ટાટા ટિસ્કોન 550 SD. સમજદાર બનો, બહેતર પસંદ કરો.
બધું ટીપ ટોપ. માત્ર આ દવા કન્ટિન્યુ કરવાની છે.
Friends, take your seats. Friends,
શું
I
engineer
request you
સાહેબ?
to take the seats.
અચ્છા, હું નીકળું છું. નવા ઘર માટે મટીરિયલ ખરીદવું છે.
TMT રીબાર કયું યુઝ કરશો?
TMT રીબાર?
જી હા, એક સારો TMT રીબાર બિલકુલ આ દવાની જેમ હોય છે. જેમ આમાં સોલ્ટ અને મિનરલનું પરફેક્ટ મિક્સ છે, તેમજ એક પરફેક્ટ રીબારની સ્ટીલમાં સિલિકોન અને મેંગેનીઝનું પરફેક્ટ મિક્સ હોય છે.
એવું TMT રીબાર છે કોઈ?
ટાટા ટિસ્કોન 550 SD. એનું પરફેક્ટ મિક્સ એને આપે છે બહેતર તાકાત અને લચક, જે આપણા ઘરને આપે બેમિસાલ સુરક્ષા.
બરાબર છે.
પરફેક્ટ છે.
પરફેક્ટ છે.
ટાટા ટિસ્કોન 550 SD. સમજદાર બનો, બહેતર પસંદ કરો. ક્યાં જાઓ છો સવારમાં?
અરે ચિંટુ એન્જિનિયર, ઘર બની રહ્યો છે ને, TMT રીબાર્સ લેવા છે.
કયા?
કોઈ પણ સસ્તાવાળા.
અને આ નવો ફોન
હા.
આ કેવી રીતે લીધો?
આ સ્ટોરેજ, કેમેરા, ડિસ્પ્લે બધું ચેક કરીને લીધો.
અચ્છા, તો ફોન માટે આટલું રિસર્ચ અને ઘર માટે? એટલે ટાટા સ્ટીલ આશિયાના પર રિસર્ચ કરીશ ત્યારે ખબર પડશે કે ટાટા ટિસ્કોન 550 SD માં છે બહેતર તાકાત અને લચક, જે આપના ઘરને આપે સુરક્ષા સાથે સેવિંગ્સ પણ. શું થયું?
પહેલા રિસર્ચ કરવું છે ને.
ટાટા ટિસ્કોન 550 SD. સમજદાર બનો, બહેતર પસંદ કરો.
ગુડ વન.
સર,
અરે ચિંટુ, તું અહીં?
હમણાં જ આવ્યો દિલ્હીથી.
એમ?
સાંભળ્યું તમે ઘર બનાવી રહ્યા છો?
હા એન્જિનિયરજી, અહીં જ તો પાછળ.
અરે વાહ, પણ TMT રીબાર કયું લીધું તમે?
TMT રીબાર લઈ લઈશું કોઈ? નો 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 નો, પાછળ.
સર, એવું કંઈક લો જે આપના હાઈ જમ્પર જેવું હોય.
એટલે
જેમ જમ્પ મારવા માટે જોઈએ બેમિસાલ તાકાત અને કમાલની લચક, એક સારા TMT રીબારમાં હોવી જોઈએ આ બંને ખૂબીઓ એકસાથે.
જેમ કે
ટાટા ટિસ્કોન 550 SD. આમાં છે વધુ તાકાત અને લચક. હવે વાવાઝોડું આવે કે ભૂકંપ, ઘરની સુરક્ષા પાકી.
અને આનું સિલેક્શન પણ.
ટાટા ટિસ્કોન 550 SD. સમજદાર બનો, બહેતર પસંદ કરો.
બધું ટીપ ટોપ. માત્ર આ દવા કન્ટિન્યુ કરવાની છે.
થેન્ક યુ ડોક્ટર સાહેબ.
શું એન્જિનિયર સાહેબ? અચ્છા, હું નીકળું છું. નવા ઘર માટે મટીરિયલ ખરીદવું છે.
TMT રીબાર કયું યુઝ કરશો?
TMT રીબાર?
જી હા, એક સારો TMT રીબાર બિલકુલ આ દવાની જેમ હોય છે. જેમ આમાં સોલ્ટ અને મિનરલનું પરફેક્ટ મિક્સ છે, તેમજ એક પરફેક્ટ રીબારની સ્ટીલમાં સિલિકોન અને મેંગેનીઝનું પરફેક્ટ મિક્સ હોય છે.
એવું TMT રીબાર છે કોઈ?
ટાટા ટિસ્કોન 550 SD. એનું પરફેક્ટ મિક્સ એને આપે છે બહેતર તાકાત અને લચક, જે આપણા ઘરને આપે બેમિસાલ સુરક્ષા.
બરાબર છે.
પરફેક્ટ છે.
પરફેક્ટ છે.
ટાટા ટિસ્કોન 550 SD. સમજદાર બનો, બહેતર પસંદ કરો.
Friends, faculties are here. Please take your seats. So the faculty will take the soil structure interactions, how we can incorporate the same in ETABS. So be patient. The new things that all are eager to learn is with the faculty.
So welcome back. Let's discuss in the ETABS how we are going to consider the soil structure interaction, how to model this, and what are the responses that we are going to get. So I prepared this model. It is the same model we had discussed in the first example. It's a fixed based. Now this has been converted into a raft supported superstructure, right? So what we are seeing is the raft at the base level instead of fixed or pinned typical supports that we are saying for the superstructure analysis. Now it is kind of interacting with the soil with the help of the area springs that we define as a soil support to the raft. So now the flexibility is different than a fixed support base, right? It's a conventional thing that we only focus on the superstructure and then the support reactions or the forces from the above at the foundation level that we can extract and then do the design of the footings in case of raft, or combined then we can use the safe program you would have already used. And the simple transfer is there and you can do it. So ETABS, in the ETABS I mean you can model this raft and we specify these soil support as area springs. That's what I had done in this model. Now in this particular model, you can see the base raft here and its section properties are 500 mm thick, M30 grade, and shell thick I have used. It's a matte type. Shell thick and thin. So in the formulation, finite element formulation, so when you consider the shear deformation along the thickness, then it is thick, right? When it is going to be significant, when the ratio of length of the slab to its thickness is around 6, less than 6 or 7, then it is going to be a thick. In a floor slab or a RCC wall that we model as a shear wall, it is going to be thin. So we are ignoring the shear deformations in the thickness direction, that's it. So you can see this. Yes. Right. Thick, yeah. For yes, yes. Height. Just I mean, imagine the area object, isolation. Don't imagine as a connected member. Just an area object. Its length and breadth is there, whichever is. Yeah. Depth. Right. So you can see this property. I think it is not clearer now. It should be okay. It's R500, and then So soil springs are supposed to assign here, but I have applied it differently, just to give you an idea how to apply these in a different manner. Directly you can assign the soil springs as area springs, right? That we do. But in this model, I intentionally created some null area objects just to specify two different soil springs, whether it's a soft soil on one corner or one side of the building, right, at the raft level. And then so I split this into this much, and now this is having a soil spring, and this one is having different soil spring. So I'll just quickly show you these definitions. So this is 20,000 soil subgrade modulus, the other one is 10,000. So don't worry about the numbers, just focus on the difference. And this raft, so these are vertical springs in the Z direction, right? Only the vertical. Laterally, it is not supported. So we can apply this lateral support provided by the soil itself in terms of restraints, joint restraints or springs or line springs, right? You can do this, but what I had chosen for my model is at the corners of this raft, I assigned some springs. You can work out this spring stiffness, some fraction of the actual vertical stiffness, just to take care of the lateral displacements. There is no a proper guideline on that, but you can assume about 10 to 25% of the vertical, that range. I think now the code is also giving the horizontal stiffness. I think you can use that also. Maybe you can check this with Murthy sir also. He will be able to give like a better idea on that. But typically it will be more or less the same, because the same earth, right, that laterally you are going to get the support. So it is fine. So those are point springs. I applied these in X and Y laterally, that's all. Right. You need to calculate as a point load. Just assume that the width of the raft, there is some thickness, so you got the area. So apply some 20% or something like that in the lateral spring. Then you convert it into 2 point loads, like as a spring constant, some displacement. That should do. So this is the setup from the fixed base model to this one. Second thing I have done in the model is I have introduced time history analysis also. I'll come to that shortly, but let us focus on the linear static analysis. Let us perform the analysis. So this is not related to the draft code, just general analysis procedure, right? So values will change accordingly. Right. So check the mode. So with the raft, the flexibility of the foundation available, right, and the superstructure, now you can see the time period is around 1.228. I think with the fixed base it would be around 0.6 or 0.7, somewhere in that range, right? Yeah, time period has increased. So because of the more flexible now instead of a fixed base. So this change, this will also affect the distribution, force distribution also. I think code is also suggesting to model the the foundation system, right? Especially when you're doing the pedal analysis also. Right. Now program has this a particular output called soil pressure. Just before that, we will quickly look at the deformation. Let's say okay, just for the gravity load itself, you can check. I'll switch to the plan view. I think the fonts is pretty low. Okay. So this edge is about minus 2.5 mm settlements, right? Now this edge where the soft soil, so it is minus 5.2, so as expected. Right. Same, you can see the pressures. Soil pressures for just the gravity load itself. It's about 40. This is about 30. Here at the edges it is higher. So basically you can capture this with this modeling, right? And the more you can find in the superstructure force distribution also, that you can see, right? Now in the soil structure interaction, one is this basic modeling of the raft itself with the soil springs, but you will get to see more information when you perform a time history analysis on this, especially compared to a fixed based model. And then what is the responses at the superstructure for especially the displacements, acceleration, floor acceleration, right? All of these. So for just to show you how ETABS is producing this, I am going to perform a time history analysis. You can, we can. Yeah, it is the same procedure there and in the here. We can model it as a drop element, define it as a drop, shell thick drop, and you can model it. So I want to show you a couple of things here. This is relating to the code also. If you are developing a site specific response spectra, right, you want to create a site specific, and then so the procedure is given there. What are the steps? Basically the steps you have to follow by taking a reference spectra for that region, and based on that, and then you will have a real-time earthquake data. So if you are testing this particular structure for various types of earthquake records like near field or far field, then you'll select various types of earthquakes, and from that you are going to derive your own design spectra, especially for special structures like nuclear power plants or some other factory buildings, right? So then you tend to develop a site specific spectra. There is a particular class that talks about it. So program can help you on that as well. So that's what I'm going to show now, but I'm going to keep it very simple. The steps and the number of records and other things are that you need to take some guidelines from standard procedures, and you can use it. But the basic things that we are going to use will be the definition of functions, So under the time history function, so we have these options. From file. So this, what I'm going to do is I'm going to import a actual earthquake record inside the ETABS. So that is through the from file option. You can get earthquake data from various resources, right? So this is, for this example, I'm going to use some sample earthquake given in the program itself. Okay, from file, and add a new function, and you can browse in the install program location. You can find this. So there is a folder called time history functions. Let's say I've used Altadena already. I'll just, for demonstration, I'll use this particular time history. So you see, you can each earthquake has 3 records, 2 laterally and 1 vertical. All 3 are available. So typically you'll get these 3. So for simplicity, I'm taking only one direction, and you can see the program imports the record like this. So basically you'll have to ensure that the file format and the data read by the program are correct. So if I open the file, it's basically like this. El Centro array 6. This first 2 lines is giving you the information about the earthquake, where station location and what is the data and what is the delta T value. It is at 0.01 centimeter per second square. So 3900 records, 909 exact. So in each line you have this 8 points of data per line. So some records will have time period and acceleration in 2 columns. Some will have only acceleration, just you need to specify the time period. So various types of presenting the data. So we'll have to ensure that program has read it correctly. So this has to be at the interval of 0.1. 2 header lines to skip, and number of points 8, like this. Right. And then you get to see this 40 seconds of data. All right. And you can import it. That will be added. So there are some guidelines which say 7 earthquake records per your time history analysis. So you can have n number of records input in this. Now let's focus on only one record and what we are going to do with that. So I used Altadena, similar 40-second earthquake, similar data, 0.02 seconds interval. It is just the time history function. Now next we will move to the load cases, and I have defined one particular nonlinear static case called gravity. This is for the application of dead and live loads, all the gravity loads, right? And it will be a nonlinear static case from 0 initial conditions. Loads are applied, And this particular case will be used by the time history case. So stiffness at the end of this gravity case will be used for the lateral load analysis, which is the time history analysis. So that is a time history case, and in that I have used the subtype as nonlinear direct integration. You have the linear and nonlinear, I think. So linear model, nonlinear model, model based time history analysis, and then direct integration, linear and nonlinear. So I've used nonlinear direct integration. Yes, it depends what we are interested in. You can do linear time history analysis, so material nonlinearity will not be considered. So when you do nonlinear, the material nonlinearity will be considered. So I will try to show you what is the material nonlinearity, how we capture that in an analysis. So the initial condition at the end of the gravity load case. That means all the gravity loads are acting on the structure, then the earthquake strikes. So what is happening to that? So that response you will get from here. So I've used TH1 function, which is what I want to discuss. I'll come back to that. So it is an acceleration time history in U1, which is in x direction, this particular function, and I worked on the scale factor a little bit. So don't worry about the scale factor numbers. It depends what is the input is. And I've asked for 20 seconds of response of 0.02. The same output, same time step as the input, right? And the damping for the structure I have specified with the period. I think this model is having 1.2 for the first time period, 5%. Just a moment. It's 1.28, something like that. This is an approximate way to give the damping to the structure. As viscous damping. Second bit will be around 0.5, I guess. So you can work out alpha and beta. So damping equal to alpha m plus beta k, stiffness and mass proportional damping. That's what we are trying to do here. So don't worry about this, you get enough guidelines from the structural dynamics books. Like Eka Chopra, in that they has explained this very well. And the time integration step, I mean, we are choosing either Newmark or HHT, right? Okay. Right. Coming back to the function, time history, and you see this TH1 was used. Now what is TH1? I will show you. So it is a time history match to response spectrum. So this has to happen because this record, maybe assume that we are doing the design of the building in India and this record is from the US, some other location. So we are trying to match to the design spectrum. What is the PGA level? We are designing this. So PGA has to be decided, even though it is a site specific. We'll have to have a reference to the codal spectra from that. So I'm using IS 1893 as a reference. You can see target response spectrum, and I'm doing the matching to this particular time history. And you can see this is the actual, and this is what the matched. actual, this is matched for the spectra. So once you have, this is for only one record. Once you have got the spectra for multiple time histories, then you'll make an average. Some averaging procedures are also described in some guidelines. You can follow that and get the averaged site-specific response spectra. Now that you will use in your response spectrum analysis. Right, so this part is about getting the average unsmoothened response spectra, and then you can smoothen it out with certain procedures, simple procedures will be there. Then you can use it in your other analysis. So you can see the matching has happened, and the red one is the actual reduced one. So some scaling you will have to do, like whether the input record is in centimeters and the model is for millimeter per second square, then you'll have to multiply it by 10, and then based on this spectra which I had used, it is normalized for G, then again I'm going to multiply it by G there. So that's where you see that some numbers there in the scale factor. So that you will have to do. So all in all, you will have to define these functions, multiple time histories, and get can work out. So program is already giving you this as a feature, right? So that's why I've used the TH1, that US record scaled down to Indian response spectrum, design response spectrum, and that is being used. All right. Now the load cases we have seen. I want to show you the response quantities that we are interested in. Let's run the analysis. These two also. This is okay. So when you go to the deformed shape for the settlements, or let's go to the pressures directly for this time history case, right? So now you have the options how you want to see this. Okay, based on the time steps, you cannot go through the time steps because there are like 1,000 outputs. Now it's a history of data where we'll find at each time step, but you can go with that if you want, but you always get the absolute maximum which we are interested in, or you can go for the maximum or minimum. Let's go with the maximum. Okay. Okay. Right. This is about 37, and here about 50 and 40. If I go with the minimum, so minimum will be the compression, right? So it will be minus maximum. I think absolute maximum is 95. It's not visible there, but and you can see this is 46, and here it is 50 in that range, right? So what is happening with the superstructure? That's what we are more interested in. Let us see that. I have created some plot functions, display plot functions. So this is the base shear for this structure, I mean, as experienced, so it is maximum of I think 2900 kilonewton. You can see the peaks. But what we are interested in the displacement and accelerations of the superstructure. So for that, we'll have to define from here. So it is basically the function we are setting here for the vertical and horizontal. So typically the vertical will set functions or define functions from here, define plot functions. Let us see the roof level acceleration. That's what we are interested in. Joint acceleration. You can select any particular joint from the model. You can easily define this. Acceleration will be absolute. Ux, so it is at the roof level on particular joint. You can select which joint you are focusing on. Right. Let's compare it with another acceleration at the base level. We'll call it as base absolute acceleration. So we'll select a joint at the base. Let's keep it as 1. Ux. Then now I'll change the functions. For the y, I'll remove the base. I'll add base and roof together. Okay. So blue is roof level and base is green. Right, you can see the green one somewhat lesser compared to the roof level acceleration. It's millimeter per second square. So not only this, you can also include the even the velocity output or displacement output. Yeah, so you have the options to export this data, show it in a table, etc. So I'm skipping those. Can explore those options. So the new code, the draft code currently is also giving the procedures to work out on the stiffness values, how to arrive at the stiffness. Then that it is something geotechnical engineer will have to deal and give it with us, but it has to be in conjunction with what this code is also. So field test based estimation basically. So that part is for the geotechnical engineer to give us. So yes, sir. No, no. I think this is what we want to cover. But if you are interested, I can show a base isolation or something like that. You want base isolation? Just 5 minutes, 5-10 minutes. That's nothing more than that. Okay. So let me check. I have a ready model so that. a very simple model just to give you the fair idea of how this can be done in ETABS. It's a base isolated portal frame. It's a study example, not real structure. So just focus on this portal frame, and it's a steel frame, but it's been isolated at the base level. You can see this. This object, which is called link, right, modeled at the base level. So this is an energy dissipating device, right? So I believe most of you would have heard about. I think Gujarat, they're already widely using this. Base isolation techniques are there. Yes, Bhuj Hospital. After that, apartment buildings and many things they have introduced. I think it's quite common. Maybe in the future it will be quite common to have. No, I heard. So there are some apartment buildings also, right? Yeah, I recently, I think Baroz, right? Yeah, residential भी है. Yeah, ground level only. So we are modeling only the superstructure above that. Yes, sir, you can do. I will show you what. I will show you what are the responses. Typically, the acceleration and the displacement of the isolator at the isolator level itself. Those things you can see quickly. So, how the isolator has been defined using a link definition. So you can see this particular link. It is a rubber isolator type. So there are options to define other types such as dampers. You have the common Venn model, plastic Venn model, to define the multilinear curve of the force deformation behavior. So I have used rubber isolator, so which is most common one so far used in India. So I'm using this. So I'm assuming the vertical, it is highly incompressible material, so it is fixed. So my focus is on the shearing deformation of the isolator laterally, right? So the lateral, it is a non-linear behavior, something sorry, like this. So the definition is will go like this. The nonlinear properties: stiffness, yielding strength, and post yield stiffness ratio. Basically, what we are trying to do here is this. Let me quickly show you. Sorry for this sketchy drawings, but just wanted to show you this. So basically the force deformation behavior, right, that is what will be given as the definition here. So it will be attested from the manufacturer. They will give you these information, and so this is force and this is deformation. So it will go through the cyclic effect or the effect for the earthquake to and fro motion, right? So it is going to dissipate the energy at this level so that lesser energy is transferred to the superstructure. So everything is contained at the, not everything, almost is contained at the base level or the isolator level itself. So that, so just giving a small idea, but there is a background and other studies related to that. But this is what I want to show. That's what this particular curve is, what has been modeled or defined here as a stiffness, yield strength. Yield strength is at the point where the kink is starting. That is the yield strength. And what is the ratio between the K1 and K2? Typically, this curve will be somewhat having a Bashinger effect, and then this to and fro with the cyclic motion, right? Loading and unloading, yielding and then unloading, like this. So it is typically idealized as a bilinear curve. That's what you see in this one, bilinear idealization, and this is specified as input. So forget about the numbers, just the definition. This is in U2 direction. So you are already using ETAB, so you know the 1, 2, 3 of a line element, local axis. 1 is along the length, 2 and 3 will be on the sectional sides. So this is only for a portal frame, so I'm defining only in direction 2. Right. So there are other settings, but primarily this is what we will be defining here. Right. And this is subjected to a real-time earthquake data, so which we had already seen there in the previous example. Some Altadena earthquake, acceleration in X direction for 20 seconds. Right. Some more preparation related to the damping and other things, because this isolator will have a higher damping than the structure. Right, it may have up to 20 or 30, even 30% of damping. Structural damping is about 5%. Right, so this is taken care in the definition like this. I already shown you that in the damping section. So you can see it 1.44 second and 0.1 second. So this assumed 15%. And structural damping is 0. This information you can get from this time period information from the model analysis, and the assumed damping from the manufacturer, you can get it from this, right, from testing basically. So this will do. Let's go ahead and perform the analysis. So under the deformation, you'll get to see this. I mean, let's quickly look at the model, so you'll get to see this effect. You can see 1.44 seconds. The superstructure is almost firm, right? But the isolation is the first mode, isolation mode. Right? And from the second mode, you can go ahead. This will be a structural mode. Beyond that, it is a transition basically. So, and you'll get all the structural modes after that. So primarily it will be, the first mode will be the isolation mode. Right. So, all right. So we have done the analysis. Now you'll get to see the link, the isolator level. What is the we want to see the shearing, right, force deformation. This is the response. What we are given as an input, FD curve in the isolator. This is the response of the link or the isolator. Right. And we will also get the responses of the superstructure. I think, let's see, we already have these. Yeah, we have the ground acceleration and then roof acceleration both. And you can see this pink color lines. You see ground acceleration data, I mean there is input data, and then the roof response, which is in blue, which is contained with the effect of the isolator. Right. So one crucial parameter that we see in these kind of studies. Right. So this can be coupled with your actual soil structure interaction. So that's what we had seen in the previous example. So but I want to show you the base isolation model. So that's why I showed you this. So one last example, just give me 2 or 3 minutes. This will be on the collapse mechanism that we had discussed in the morning. session, like where are the locations in the structure that has started yielding in an event of earthquake? How do you find this? Through, obviously it is through the nonlinear time history analysis, but where the plasticity, it is distributed all over the structure, but these are at specific locations where the collapse mechanism will form. Like if you have a simply supported beam at the mid-span, right, where at a certain point of load, beyond that it is going to yield, and then it will fail, right? In a continuous frame or a portal frame like structure, then again it is at the ends of the members, whether it's a column or beam. So I have a small example on that. I will just demonstrate that quickly. So you can do this using a time history analysis or actual input data, or you can also do a pushover analysis. So in this I'm going to use the pushover just to give you idea it can be done in this program. So pushover analysis forms the basis for the performance-based design. That's the next or the future in the design. So we are dealing with the ultimate limit state. Right? Next is performance-based design. Program is already capable of handling those. So we set performance criteria and objectives and design the structure for that. Now let's focus on this. Again, it's a simple steel portal frame. I have assigned hinges, frame hinges, non-linear hinges like this. These are the expected regions of the members where we expect non-linear behavior or the yielding will happen. So there are two options. One is automated. Again, program has the automated feature based on FEMA and ATC 40 documents or the ASC 41 code. So you can refer to that, or you can define your own definitions under the define section properties, frame wall nonlinear hinges. You would have seen this. Most of you would not used it, but it's very easily done. You can define. So these are auto generated. Let's say if I take a column or a beam, let's say I'll take a beam hinge and I'll show you it's a deformation controlled hinge definition. So these parameters are from that particular automated code based values, but basically what you're defining is the yield, the yielding point, and then beyond yield strain hardening, and then the failure, right? So this is the backbone curve that we define for this hinge. Same goes for a column, PM3 hinge, the interactive axial and uniaxial. This one is. So basically it is the moment versus rotation, plastic rotation, right? So that definition for different axial levels. So the hinge definition. Okay. So these columns and beam hinges are already applied in this model, and we are going to perform a particular analysis which is called pushover analysis. I will show you how this is defined. It's basically nonlinear static analysis that uses the material nonlinearity through that hinges we just defined and assigned. So load application is like we are going to apply this load in steps for a expected magnitude of about 200 mm for this example, but this 200 is coming from the drift limits or some set by the codes, or expected displacement for a particular earthquake data itself. You can assume those, right? So basically the structure is going to be pushed laterally to 200 mm in steps, and at each step there will be analysis result for you, and through these steps you can see which are the members are yielding and maybe failing. So the collapse mechanism can be easily identified in this. So this one, let us see. So it's a fixed base, not an isolated. You can do this in isolated, but typically in isolated we expect the superstructure remains elastic. You can, if you assign the hinges to the isolated model, you will see it will be elastic, it will not collapse because energy is taken by the isolator, right? So all right, it is done. It is done. Let's look at the push. Again, I had started this analysis at the end of a gravity load case, same as the time history. So you can see the push step number is 0. That means gravity loads have been applied. That's what this deformation tells us. Now you'll have number of steps. You can increase it here, or you can use the toggle button. Step 1 out of 14. Yeah. So this is 7. Step number 7. The deformation is about 122 mm at the roof level, and you can see some of the members have started yielding, but it is still within this yielding region only, right? Let us see. So you can see this particular column has yielded or reached that ultimate. And the second column is just near to that. That was the last step for 200 mm. Right. Now if you want to see the, I'll select this particular column. Okay. I'll go to the display and get to see the hinge results. What is happening with that? You can see the moment rotation. It is at this region. It has yielded, so it is in the negative, so it is yielded, and then this is the ultimate point, and then it has dropped, then it is continuing still. Some other, there will be load path effects will be there, right? So some members will take from the redundancy effects and other things, so load path will change. So it will not collapse immediately, so these paths will steadily in progress, and then final collapse will happen. So but this is a wonderful analysis that is available within the program. This is done in steel structure, but you can do it on the RCC also. One more item in this, which is the pushover curve. So you can see the pushover curve. It's for the whole structure. Let's roof displacement versus the lateral load applied. So it gives a fair idea of something is happening where there is a drop, so members are dropping. Okay. So for RCC, this forms the basis for retrofitting. So if you are strengthening or retrofitting an existing building, you want to know the capacity of the building, right? What is the current capacity? Whether it is, let's say you are protecting a monument structure of any material, right? So you will have to identify the moment rotation through the nonlinear definitions, and you can apply this, and you can check its capacity against the new demand, new earthquake forces, maybe new zone factors that we have been. So this can be completely studied in this program. So these are the features I wanted to show you in this presentation. I hope it has given you new thoughts And you had some queries in the morning. I hope I tried to answer all of them. If you have any questions, then please let me know. I'll try to answer. Finish. All right.
If you have any queries now, please do write to us. We will definitely send it to the CSI team. Okay? And we will get that answers of it. Okay? Please.
Yeah. So thank you all for giving us the opportunity. Thank you, sir. It's a wonderful session. All right. Once again. Yeah, sorry. You want
Good afternoon, everyone. Once again, a warm welcome to everyone present here. Thank you so much for taking out your valuable time and be with us for tonight. I hope this session has been fruitful to you all till now. I am Jainam Shah from Aryan Steel Agency, Surat. We are authorized distributors for Tata Steel in the region of South Gujarat. Today, just like we saw, ETABs giving us the right design solutions to our community. In the same way, we at Tata Steel, we are providing the right product that complies with the design as well as the IS standards. So I think in today's market we have a lot of choices when it comes to rebars, but I don't think a lot of rebars would actually comply to the IS 13920, and nowadays it's just a matter of marketing for everyone, but in that case we are losing the sole purpose, the chemistry, the flexibility, the strength which a rebar should actually provide to a structure. So my session today is about 2 points. One is our product, Tata Tiscon 550 SD, and the other one is our program which we have for the community of architect and engineers. We call it the Grand Masters program. So, like I have presented a small presentation about how a journey of a consumer begins. So the first things which arises in his mind would be which rebar should I buy which provides safety during earthquake. How can he buy from the comfort of his home without going out and simply online buying stuff online is very trendy nowadays. Another is a question that arises in a consumer's mind is how can I save my material cost and overall cost of my project of my dream house. And this is where the role of an architect or an engineer or a structural designer comes in. He would help his consumer with durability and aesthetics, along with smart budgeting, and also a reputation and a reference that comes along when a customer approaches to an architect or an engineer or a structural designer. He would come up with let's say, a preoccupied reputation which he has heard from his colleagues or from his neighbors, along with the brand with which engineer associates himself. So these are the points, architect would play an important role when it comes to an individual house building. So I've heard a lot of people in retail market, they say સળિયા તો સસ્તા લઈ લેવાના, દેખાવાના થોડી છે, બિલ્ડિંગમાં જતા રહેશે, બરાબર, ટાઇલ્સ મોંઘી લો, બાથવેર મોંઘું લો, એ બધું તો લોકોને બતાડવાનું, મોટું ટીવી લો. But a lot of people fail to understand that rebar is like a backbone of our body, though it is not visible. But if something goes wrong with our backbone, the next thing is paralysis. The same way, if a rebar or a material which is used in your construction, even though it's not visible, any deformation to it may cause catastrophic events. Like Vivek sir explained, the code also has been changed because the seismic zone has been updated in India, and if you especially look at Gujarat, our seismic zone has been increased. It is now 3, 4 and 5 in Gujarat. Previously it was 2, 3 and 4. So higher seismic zone means higher frequencies of earthquake in such areas. The IS code of 13920 in 2016, it says that seismic zone, like places like Gujarat having 3, 4 and 5 seismic zones are highly prone to earthquakes, and in such areas the ductile designing and design of reinforced concrete structures should be made in such a way that they are able to withstand such high earthquakes. The minimum UTS to YS ratio of a rebar is suggested to be 1.15. This is where our product comes into play. We call it Tata Tiscon 550 SD, which is the only rebar in India which complies to IS code 13920. Why? Because we call it Behtar Takat. We give 550 MPa grade, which is minimum yield strength, that is 550. We give highest of UTS YS ratio, that's why we call it Behtar Lachak. And along with that, we say Behtar Bachat, because when you design a structure with 550 grade instead of a 500 grade, which is very commercial these days, you guys can save up to 6% of overall steel consumption in an building. I have a few studies on the next slide, I'll show you. Like I said, our yield strength is minimum of 550, UTS to YS ratio is 1.15, and our elongation is minimum 16%. If you look at the competition, nobody is even near to what we are offering when it comes to these three factors. I think I don't need to explain you guys the significance of UTS and YS, because you are all more educated than what I am. But this is the design load. The deformation of a rebar starts when the load increases above the design load. After that, the ideal condition, the curve you see in yellow, it is of any other rebar which is of 550 grade. And when the load increases beyond the breaking point, you see the UTS of Tata Tiscon is way higher. The curvature is way higher than any other brand of 550 grade. So the higher UTS means the extra energy can be dissipated before deformation or before collapsing of the structure. When we say that our elongation is minimum of 16%, but this 16% elongation, it comes to play when there is a let's say earthquake is going on, and the first thing humans react is to move out of the building, right? So we need that space of time, we need that frame time to actually evacuate the compound. So when there is this high elongation in a product, it gives you extra time to leave the premises you might see some visible cracks, you might hear some sound instead of sudden failure of the structure. So nowadays people are offering rebars only on the basis of price, but when we see, when Tata Steel offers a product, it actually implies to the government standards. This is what it should be, this is what the government has asked to the steel companies to design their rebars in such a way that you should get such elongation and such high UTS to YS ratios. Here I've shown in a graph. So what happens when the load increases? Most of the rebars, they fail without giving any warning. They act brittle. There is this point જ્યાં લોડ વધે છે ત્યાંથી સીધા બે ટુકડામાં તૂટી જાય છે. And when it comes to Tata Tiscon, જ્યારે લોડ વધે છે તો પહેલા એનો શેપ ચેન્જ થાય છે. The product changes its shape. એ બારમાંથી એનો એક પોઈન્ટ લોડ બને છે. તો એ જે ઇલોંગેશન થાય છે 16% સુધી એ પ્રોડક્ટ ખેંચાય છે. રીબાર પહેલાં સ્ટ્રેચ થાય છે, એના પછી એ પોઈન્ટે આવી શેપ ચેન્જ થાય છે. સો ધીસ એક્સ્ટ્રા ટાઈમ વિચ વી આર ટોકિંગ અબાઉટ ડ્યુરિંગ અર્થક્વેક્સ દેટ વી નીડ ટુ એવાક્યુએટ ધ બિલ્ડિંગ, અને એના પછી એ ફેલિયર આવે છે. So like I said, this gives more time for the occupant to vacate the house. These are the test certificates of prominent brands and Tata Tiscon. I think it's not clearly visible, but what we say is also actually proven, and it comes along in our test certificate. So nowadays we're hearing a lot of terms like eco-friendly, nature-friendly. Even Narendra Modi ji is also driving the nation towards zero carbon policy. So we are the pioneers when it comes to Green Pro certification. Tata Steel was the first company in India to get Green Pro certified from the government. So when we say behtar bachat, what does it actually mean in Tata Tiscon? So if this is a ideal condition, a 250 square yard building area, G+3 is the common criteria we're considering. If you design your structure with 550, FE 550, the kg per square feet is 3.60, and the consumption drastically decreases when you design it with 550, FE 550. So this is where we actually say that by using 550 grade, you can actually save on overall steel consumption. So this is how customers analyze engineers or architects, before consulting. Your past work, your previous good structures, association with top brands, and positive word of mouth. This is the reasons why a customer would go up with an architect or an engineer. So I'll just show you a small video on our program, which is Tiscon Grandmasters, and after that we'll talk about the program in detail. Sound.
The consumer is the king of his dreams. And he's building his palace. It's a once-in-a-lifetime investment where he is in anxiety and dilemma.
કે ભાઈ આખી જિંદગીમાં કન્ટિન્યુઅસ એટલું બધું પાણી પડેલું હશે કે કલર પણ બદલાઈ ગયો છે તમારો corrosion is also settled into the concrete. It has penetrated the concrete. This is another example. In we have seen કે ભાઈ ગુજરાતમાં સોલારનું ચલણ બહુ વધી ગયું છે કે ભાઈ one of the highest manufacturer of solar energy in Gujarat in India. So you in 80% of cases, this is a classic example where this is terrace slab, 4 ઈંટ મૂકી દીધી અને એની ઉપર box section મૂકી દીધું. હવે એમાં શું what is the connection between the box section and brick, and what is the connection between brick and the RCC slab? તમારે કોઈ આપણે મસ્તીમાં બી if I just hit the brick, we don't know, we cannot imagine the consequences. Another very nice example on the left hand side where you can see on the central portion by building જ્યારે બન્યું હશે ત્યારે એ સમયે GI ના પાઇપ ચાલતા હતા તમારા. We can see it has corroded like hell. તમારે એટલું બધું કે ભાઈ એ લોકોને તકલીફ તો પડી એટલે એ લોકો એ પાઇપ રહેવા દીધો, બાજુમાં PVC નો મૂકી દીધો. હવે પેલા પાઇપને એ લોકોએ ત્યાં જ રહેવા દીધો. They have not even shifted that pipe. So એનું તો કેવું છે કે ભાઈ શું થશે શું ની ખબર નથી, જ્યારે કોર્પોરેશનની નોટિસ આવે ત્યારે જોઈ લેવાનું. And another is an example where there was a core drilled out from a beam and you can see throughout the diameter of the core there is no concrete. These are all electrical saddles, electrical pipelines. This is also another case where nowadays in commercial buildings mechanical and stack parkings have increased very rapidly, the usage of stack parkings. So you can just see that do you even think that the member sizes that are provided for this stack parking are even capable of resisting the lateral loads? They are just what we can understand. They might have been designed considering its self-weight and the loading of cars that are going to rest upon. And also these things, see, I am also confused about this second image, whether this is right or wrong. My only question is that is there any other possible way where we can just relocate or rearrange these PVC pipelines in such a manner કે ભાઈ અત્યારે throughout the slab there are holes. I don't know, it might be we can just there might be an option where we can just create a pocket where we can just collectively take down these pipes throughout the levels instead of poking holes at wherever we want or wherever the MEP consultant says. So ultimately the main purpose of this presentation was to just I know we public sitting here, we all are aware of these things, but please pass on the message to the other stakeholders of your projects that what is the importance of placing AUs or non-structural elements on our buildings, because in some cases it damages very badly and ultimately કે ભાઈ everyone, even I would doubt કે ભાઈ ડિઝાઇનમાં તો ભૂલ નથી ને ભાઈ, આવું થોડું થાય તમારે ક્રેક પડે. પણ પછી they don't know કે ભાઈ 10 ફીટના કેન્ટિલીવર પર as I said earlier 1000 kg નું પોટ હોય, પોઈન્ટ લોડ પડે, એની જ ને આપણને તો જાણ જ નહીં હોય. આપણે તો ક્રેક પડે એટલે ભાઈ ક્રેક પડી છે નીચે અને આપણે જઈએ એટલે જોઈએ, આપણે તો ખાલી ગાર્ડન તરીકે એને ડિઝાઇન કરેલું હોય લોડિંગ્સ ગણીને. So just pass on the message to other stakeholders of your project in which you all are associated, and let us try and solve this issue and let us see that what the code is, final code that gets published is telling us. Yeah, thank you.
Thank you, Kush. He has just started, he has just initiated. Just think about nothing else. We are civil engineers. We should start thinking in the direction for our work, for our project. let's see, many of the time what happens, everything is not available with code. Everything is not available with technical textbooks. Even I can say in 1989, I have completed my graduation at that time. Many of the things not known to me. But the thing is, we should continue our process of learning through this kind of seminar, this kind of workshop, this kind of hands-on series. Professionally, we may be engaged, we may be busy, working 12 hours, 13 hours, 14 hours a day. But besides this, for our profession, for the sake of our profession, we should spare few of the hours in a week or in a month. And I think I and Hiren, we are thinking we should provide such kind of platform for sharing technology and knowledge. And it should be like this. Okay, if anybody observes anything new, let's share with each other. Let's be bullish. In my office, not a single drawer or a cupboard having a lock. It is open for my all engineers, those who have worked with me or those who are working with me. The reason is IS codes are there. Many of the written, my calculations, my notings are there. They are free to seize. They are free to refer it. And if required now, they can take a copy of it from my office printer. They can take a Xerox copy of it. The reason is, you see, certain things, if you have something original, and if someone copies it now, and after copying it, if we improvise the thing now, then and then it is good for the society as a whole. What we are thinking is, let's be bullish for sharing knowledge and technology. And many of the time I'm telling you, I says in my office too, genius idea needs a strong support. And we are very happy to have a very strong support from Tata Tiscon. It was just a straight thought, and my friend Hiren knows this. So the thing is, someone was ready to sponsor it, and he might be unhappy to see the live streaming. I have shared that links too with them. That boss, this was the program, this was the thing. This is for the new budding engineers, and I think Manoj Bhai is the lucky enough that within 1 hour, we get that confirmation कि yes boss, मैं खेलूंगा. Thank you Manoj Bhai. Thank you very much. Thank you all.
આપણો અહીંયા હવે પ્રોગ્રામ પૂરો થાય છે. દરેક જે એન્જિનિયર આવ્યા છે અમારા તરફથી એક નાની ગિફ્ટ છે, બધા લઈને જજો, કોઈ એમને ના જતા. અને હજી પણ કોઈને જો સ્ટીલ બાબતે કંઈ બી ઇન્ક્વાયરી રિક્વાયરમેન્ટ કંઈ પણ જાણવું હોય તો દરેકના બ્રોચરમાં વિઝિટિંગ કાર્ડ મૂકેલું છે, એમાં નંબર છે, તો તમે કોન્ટેક્ટ કરી શકો છો. થેન્ક યુ વેરી મચ.
આપણે જ્યારે ઈટેબમાં સ્ટીલની પ્રોપર્ટી ડિફાઇન કરીએ છીએ ને ત્યારે નોન લિનિયર એનાલિસિસ માટે અત્યારે FE55Dમાં હું જોઉં છું FY FU FE ચોથી વેલ્યુ કઈ છે? 4 વેલ્યુ ડિફાઇન કરીએ છીએ ને આપણે. અલ્ટિમેટ અને yield 3 પ્રોપર્ટી મનોજભાઈ અમને આપેલી છે. ટાટા સ્ટીલને કહેજો કે અમારા ઈટેબમાં અમે લોકો જ્યારે એનાલિસિસ કરીએ છીએ ને ત્યારે અમે 4 વેલ્યુ આપીએ છીએ, બરાબર? 500, 545, then 2 more values are there, FYE, yield and strength અને એની. તો એ 4 વેલ્યુ સાથે અમને એક નાનો અમથો કાર્ડ વોટ્સએપ પર મોકલી આપશો ને, જે અમારા ટેબલ પર, અમારા ડેસ્ક પર, અમારી હાથમાં, અમારી ડાયરીમાં, એટલે જ્યારે પણ ઈટેબ મોડેલ કરીએ અને પ્રોપર્ટીઝ મૂકીએ ને ત્યારે એ બધી વસ્તુઓ ઉપયોગમાં આવે અમને. બાકી આ ટેબલ ઘણું યુઝફુલ થશે અમને, બરાબર છે?